Click on Next. For query or static
Welcome to this
values,
course on the Oracle Digital
under list
Assistant
entry label, enter a numeric or alphanumeric name for the
professional
list
certification.
entry. For target page ID
This
or
is the course
custom
overview.
URL,
We're
select a
glad you're
target
here and
page or
have lots
enter a
of good
custom
information for
URL
you. Daniel
where you
is a
would want
product
it to
manager who
redirect.
has also
I'll go
created
ahead
numerous
and
other
select an
trainings,
existing
design
page in
camp
this
sessions, and
application.
blog posts. Patrick, as the lead user assistance developer on the team, has written a lot of technical documentation, including user guide content and tutorials. There are a few other contributors we'd like to acknowledge. In addition to Daniel and Patrick, Himanshu Raj contributed to the development of the curriculum. And Frank Nymphius and Grant Ronald are key subject matter experts who contributed a massive amount of information on best practices. This course was designed for developers of digital assistants and conversation designers. Our objective is to help you become proficient in using Oracle Digital Assistant to make successful production quality digital assistants. To do so, and to get the most out of this course, you should have experience coding with JavaScript. You should have knowledge about using REST APIs, and it will be very helpful for you to already have hands-on experience with Oracle Digital Assistant. Since this course is all about helping you prepare to take the certification exam, it's helpful to know right up front what the exam will validate. It will test your ability to identify use cases for digital assistants. It will see if you understand how to use Oracle Digital Assistant to create digital assistants. And it focuses heavily on your ability to incorporate Oracle Digital Assistant best practices in your development work. This course is organized into 5 major modules. Let's take a moment to go through that list. The first module provides a general overview of the field of conversational AI and how Oracle Digital Assistant can help you create a conversational assistant. Conversation design focuses on the principles and practice of designing successful conversational experiences. The Design and Build Intents and Entities module takes you through the process of creating intents and entities to help your digital assistant understand user input. Module 4 shows you how to design conversation flows and also has information on creating custom components and connecting with back-end services. And the final module covers information on assembling separate skills into a digital assistant, exposing your digital assistant through user channels, making the most of resource bundles, and creating digital assistants that work in multiple languages. Each module contains multiple lessons. We recommend that you go through the modules in order, because later modules build on earlier modules. This course includes an end-to-end lab that the student can use to provide hands-on experience and reinforce concepts from across the modules. This lab uses a digital assistant for a shopping mall as its use case. The digital assistant contains separate skills for shops in the mall. To complete the lab, you'll need access to an Oracle Cloud account. If you don't already have access to one, you can sign up for a free trial account at signupcloud.oracle.com. Keep in mind that this is a fairly lengthy course. As such, we'd like to offer some tips for making your way through all of the lessons and giving yourself the best chance to pass the exam. We suggest that you take notes on topics based on your existing knowledge. And remember, you can follow along using the transcript tab. Schedule breaks each hour and move around. Don't stay stationary in front of a computer for too long. Complete all the skill checks in this course, and complete the exam preparation course prior to launching the certification exam. We here at OCI are continuously building and delivering training, integrating feedback, and monitoring user analytics. If something is broken or not resonating with our users, we want to know. That's where viewer ratings come in. Please feel free to rate this course and leave specific feedback as to what's helpful and what's not. We are constantly tweaking our approach so that we can help our audience achieve their goals. Let's join forces and work together for your learning and certification. This first lesson is an introduction to conversational AI and the Oracle Digital Assistant Cloud Platform. Let's start with a definition of artificial intelligence, AI for short. AI is a rapidly growing field with a wide range of applications across various industries, from finance and healthcare to transportation and entertainment. It has already shown great potential in automating routine tasks, analyzing data at a scale beyond human capabilities, and providing personalized recommendations to users. AI algorithms are trained on vast amounts of data and can learn to recognize patterns and make predictions with high accuracy. As AI technology advances, it is expected to revolutionize the way we live and work, bringing significant benefits, but also raising ethical concerns around issues such as bias, privacy, and accountability. Despite these challenges, the potential of AI to transform our world is truly remarkable, and it is an exciting time to be at the forefront of this innovative technology. Some examples of AI are object detection, receipt extraction, natural language processing, self-driving cars, search engines, or face recognition. In short, artificial intelligence has become a catch-all term for applications that perform complex tasks that once required human input. As such, it is at the center of most innovation initiatives for enterprises. AI consists of several subdomains, such as machine learning and deep learning. Machine learning and deep learning enable machines to learn from data, identify patterns, and make predictions without explicit instructions from a human. We can use AI to build a rules-based system to understand language, image, or recommendation challenges. Now, let's talk about natural language processing, NLP for short, which is a key part of chatbots. NLP is a field of artificial intelligence that focuses on enabling computers to understand, interpret, and generate human language. In other words, NLP tries to understand text or voice in the same way that humans do. NLP algorithms are designed to analyze large amounts of textual or vocal data, recognize patterns, and extract meaningful insights. By mimicking the way humans process language, NLP technologies can automatically classify documents, identify sentiment, generate summaries, and even engage in conversations with humans through chatbots or virtual assistants. This brings us to the concept of conversational AI. Conversational AI is when we apply AI in a conversational interaction with a human. Conversational AI is a rapidly growing subset of AI that focuses on creating natural, human-like conversations between machines and humans. Chatbots, digital assistants, and virtual assistants are all examples of conversational AI technologies that enable users to interact with machines using natural language. To achieve this, conversational AI utilizes subdomains of AI, such as natural language processing, NLP, machine learning, ML, and deep learning, DL. NLP enables machines to understand and interpret human language, while ML and DL enable machines to learn from data and improve their responses over time. And now a few words on the distinctions between chatbots and digital assistants. Both are AI-powered conversational interfaces that are designed to interact with users through natural language. Chatbots are typically programmed to serve a single purpose, such as answering frequently asked questions, providing customer support, or helping with a purchase. Digital assistants are multipurpose. For chatbots, users can initiate the conversation through a website, messaging app, or voice interface. Digital assistants can be proactive, initiating interactions with users. Chatbots are designed to respond to simple user interactions, such as providing options, asking questions, or providing information. Digital assistants can recommend or complete tasks that go beyond the scope of a single conversation. Digital assistants can even handle user requests in complex cross-domain interactions. This is due to their contextual awareness. As part of this, a digital assistant is able to do intelligent routing as the user changes topics or interjects new requests before the previous one has been resolved. You can think of a digital assistant as something like a waiter. Both do things like welcome guests and ask about their needs, just as a waiter greets guests and asks what they would like to eat or drink. A digital assistant welcomes users and asks for their needs or preferences. Make recommendations. Like a waiter, a digital assistant can make personalized recommendations based on user preferences and history. Ask for needed information. A waiter may ask for information such as dietary restrictions or preferences, while a digital assistant may ask for data to improve recommendations or user experience. Communicate with back-end services. Both waiters and digital assistants communicate with other services, such as the kitchen or data sources, to fulfill user needs. Understand context. A waiter may remember regular customers and their preferences, while a digital assistant may remember past interactions to provide more personalized recommendations. In addition, both waiters and digital assistants can be proactive in anticipating user needs, such as asking if a user wants more wine before their glass is empty. You may be asking yourself, is artificial intelligence really all we need? The answer is definitely no. Creating a digital assistant requires more than just artificial intelligence and machine learning. Here are some additional components that are essential for building a successful digital assistant. Application security. Digital assistants may handle sensitive information, so it's important to ensure that they are secure and compliant with regulations. Back-end integration. A digital assistant needs to integrate with back-end systems and data sources to provide users with accurate and relevant information. Conversation analytics. Analyzing conversations with users can help improve the digital assistant's performance and provide insights into user behavior and preferences. Conversation design. Crafting a conversation that is natural and engaging is essential for creating a positive user experience. FAQ integration. A digital assistant can integrate with frequently asked questions to provide quick and easy answers to users. Human agent integration. In cases where the digital assistant cannot provide a solution, it's essential to integrate with human agents to ensure that the user's needs are met. Model training. Machine learning models need to be trained and continuously updated to improve the digital assistant's performance over time. Multi-channel support and integration. Users may interact with a digital assistant through various channels, so it's essential to support and integrate with multiple channels such as voice, chat, and text. Multi-language support. A digital assistant should be able to understand and respond in multiple languages to cater to a global audience. Structured data input. Digital assistants require structured data input to understand and provide relevant information to users. Quality testing for utterances and conversations. Testing the digital assistant's ability to recognize and respond to various utterances and conversations is essential to ensure high-quality performance. Utterance sourcing. Continuously sourcing and adding new utterances to the digital assistant's knowledge base can improve its performance and user experience. With the rising popularity of OpenAI, ChatGPT, and other services and applications based on large language models, you might be wondering how generative AI fits into this picture. The key to large language models, or LLMs in short, is that in addition to attempting to understand the user's natural language, they attempt to generate the desired response itself. This differs from models where the AI is used to determine the user's intent, and then it's up to the chatbot developer to provide a response to map to that intent. This means that the chatbot developer has less control over tone and branding in the responses. That said, there are a number of use cases for integrating LLM functionality into your chatbots. We'll explore generative AI further in ensuing lessons. In summary, conversational AI is an application of artificial intelligence that is used in chatbots and digital assistants. Oracle Digital Assistant is a platform that enables you to create digital assistants to help users complete tasks within a conversational interface. In this lesson, we'll introduce the basic linguistic model concepts that are behind the creation of chatbots. Let's start with the concept of intents. In the context of a digital assistant or chatbot, an intent can be identified from a user's input, such as find a slot for a Zoom meeting with Steve Bennett on Friday at 10 a.m. The intent behind this input is to schedule a Zoom meeting. In conversational AI, an intent refers to the underlying purpose or goal of a user's input in a conversation and serves as the entry point for that conversation. This intent is determined by analyzing a set of related messages that a machine has previously seen during training or sees for the first time using machine learning and natural language processing techniques. In natural language processing, intents are mapped to conversations a user wants to have. By identifying the intent of the user's input, the digital assistant can provide relevant and personalized responses and take appropriate actions to fulfill the user's request. Identifying the intent is the first step in developing effective conversational AI systems that can understand and engage in natural language conversations with users. The next concept we'll define is that of utterances. In conversational AI, utterances are sample messages that represent how users would typically address an intent. Here are some examples of ways to set up a meeting. These messages are curated to provide a diverse and representative sample of real user input, while avoiding bias or ambiguity that could blur the distinction between different intents. Utterances are sample messages of how users would express an intent. A quality set of utterances has the following characteristics: represents real user messages, is curated to avoid bias or blurring, is well balanced among intents. No intents should have a disproportionate quantity of training utterances. Identifying and curating high-quality utterances is crucial for training machine learning models that can accurately recognize and understand user intent. An optimal balance should be achieved between undertraining and overtraining of the models to ensure that they can effectively handle both known and unknown user inputs and provide accurate and relevant responses. Now, let's talk about entities. While intents map words and phrases to a specific action, entities add context to the intent itself. They help to describe the intent more fully and enable your bot to complete a user request. You use entities to extract information from user messages. Here's what you need to know about entities. Entities can be real-world objects such as person, order, product, location, date, and account. They can also be business domain specific, such as products and merchants. They can have a name that is unique within the chatbot, as well as a type and optional properties to set. They can be referenced by multiple values, synonyms. NER, which stands for Named Entity Extraction, is the process of finding entity values in a user message. Summing up this lesson, intents and entities are two key linguistic model concepts you will work with when designing chatbots to address your target use cases. In this lesson, we'll provide an Oracle Digital Assistant as a chatbot platform and go over the main parts of a digital assistant. In the first two lessons, we introduced the technology behind chatbots and the key concepts of chatbots themselves. Now, let's talk about Oracle Digital Assistant and how it enables you to create multifunction chatbots called digital assistants. In their early days, chatbots solved simple business problems like automation of customer service, automation of structured processes, and self-service processes. Today, digital assistants are user-oriented. They assist users with various related or unrelated tasks. They have context-aware conversations and also can learn about the user. In short, Oracle Digital Assistants provide what users truly expect from chatbots. Oracle Digital Assistant consists of the following four core pillars. Skills, which as you will learn in a minute, are the conversational building blocks. Each skill uses artificial intelligence and machine learning to start a conversation with a user. Digital assistants, in which you can assemble individual skills to provide a combined chatbot solution. Channels, which are connectors that bind skills or digital assistants to messaging clients like Slack, Microsoft Teams, or your own web application. There are also channels that integrate with customer service centers to enable handoff to human agents. The skill store, which is available to distribute skills and digital assistants that customers can pull and customize to meet their requirements. For some technical orientation, here's a quick look at Oracle Digital Assistant from an architectural point of view. Oracle Digital Assistant is a platform as a service, PaaS, in Oracle Cloud Infrastructure, OCI, that hosts multiple digital assistants at design and runtime. Each digital assistant can use as many skills as are available for an instance. Individual skills can be linked to different digital assistants. The backend access is via REST services and is implemented on the skill. Channels interact with the messenger types they are configured for, passing user messages to the digital assistant's intelligent routing system and bot messages back to the user messenger. Now we'll talk a little more in depth about skills, digital assistants, and channels. We'll start with skills. Skills are individual chatbots that can be exposed through digital assistants and can also be used standalone outside of digital assistant. Architecturally, each skill represents a conversational module a reusable building block you can register with any digital assistant. Conversational AI, which is natural language processing, NLP, and entity extraction, NER, is at the heart of each skill, allowing the skill to have natural conversations with users. Dialogue flows define the outline of a user-bot conversation. Each turn in a user interaction is defined by state, holding a built-in or a custom-built component, and allowing for declarative development. In addition, you can use group entities to define intelligent and model-driven conversations for which you don't need to write any dialogue flow code. You can use the Intent Builder feature in Oracle Digital Assistant to define intents and utterances declaratively. Immediately after training, the machine learning model can resolve intentions from user messages for which it has not been trained. Data manufacturing is an embedded collaboration framework that allows you to send users a web link to a form that they then work with to add their sample phrases. In digital assistant development, entities are objects that allow you to extract information from user messages initially sent to a digital assistant, or when prompted for specific information. For example, when prompted to provide information about their size for a t-shirt, users may respond with XL, I am wearing XL, or I think XL will do. Oracle Digital Assistant comes with built-in system entities, which you can use to extract information like address, currency, date time, person, and email. Custom entities allow users to define a static and dynamic list of values to be extracted from a user message, regular expressions, a list of custom or built-in entities, and entity groups. Composite bag entities are like business domain objects and can be used to generate a full user conversation with the details of a particular piece of information, such as a booking or a customer account. The dialogue flow in Oracle Digital Assistant describes the conversation that users could have within a skill. Bot messages, user prompts, and logical operations are implemented declaratively using built-in, out-of-the-box, and custom components. The embedded conversation tester in Oracle Digital Assistant skills allows you to test your skill without the need to deploy it through a channel. Instead, you can simulate different environments, rich messengers, and text-only messengers to see how your skill performs. Being able to simulate different environments is important because messengers behave differently and have their own limitations, for example, in the number of action items they can display at a time. In addition, conversations you use for testing in the conversation tester can be recorded into a script for later conversational unit testing. When there is a large set of questions that needs to be answered, you can use the Web View feature to display a web form in the context of the conversation. Oracle Digital Assistant supports multiple languages through its own natural language understanding (NLU) model and through commercial translation services. In both cases, translation services and NLU native language support, you use resource bundles in Oracle Digital Assistant skills to translate bot responses and ensure your bot uses a consistent voice, tone, and attitude. Another important feature of Oracle Digital Assistant skills is Skill Insights, the analytics engine that collects runtime performance data about a skill, which enables you to determine the success of your chatbot. In multiple panels, Insights will give you information about the number of conversations your skill has processed, the number of conversations that have been successfully completed, the conversation paths your users have used, and the user messages that could not be resolved into an intent or that were resolved incorrectly. Oracle Digital Assistant has built-in support for OAuth 2-based authentication and authorization. Identity providers like Oracle Identity Cloud Service, Oracle Access Manager, Google, and Microsoft are supported for use in a chatbot conversation. You can configure your dialogue flow to require authorization at any point in the flow. A common use case for chatbots is to reduce the workload for call senders and provide other customer service support. Oracle Digital Assistant provides the following possibilities on this count. Digital Assistant as an agent. Using an integration with Oracle B2C Cloud Oracle Fusion Service Live Help, Digital Assistant becomes a peer member of the team of support agents with its own queue of customer requests to handle. If the bot can't solve a customer request, it can still pass the request on to a human agent. Live Agent Transfer. With Live Agent Transfer, if the skill can't handle the user request, it can hand off a conversation to either an Oracle B2C Service Live Agent or a third-party chat service. Integration with Oracle Intelligent Advisor. Intelligent Advisor is a service that lets business users deliver consistent and auditable advice across channels and processes by capturing rules in natural language Microsoft Word and Excel documents, and then building interactive customer service experiences called interviews around those rules. You can leverage your existing interviews by incorporating them into your skills. Knowledge Search Integration. If you are using Oracle B2C Service Knowledge Foundation, then you can use a built-in dialog flow component to search for and display articles from that service. You can also incorporate calls to large language models in your skills. This is managed through the Invoke Large Language Model component that is available in the Visual Flow Designer. With this component, you can design a prompt to an LLM based on the user's input and other data sources. And you can post-process the LLM's response in other flow states before passing it back to users. The Knowledge Document feature enables you to import FAQ from existing knowledge sources into your skill and generate intents, with a starting set of utterances for each intent. The External Events feature enables you to configure a skill so that you can use an event from an external system to proactively start a conversation with a user from an external system. For example, a calendar system could remind a user of an appointment. Finally, Oracle Digital Assistant provides its own lifecycle management for skills, including versioning, cloning, and publishing. Now, let's move on to digital assistants. Digital assistants provide a unified chatbot solution, where various user requests can be routed to the appropriate skill. From a user perspective, the digital assistant is a unified front end for multiple skills. The digital assistant's intelligent routing capability is based on NLP and routing rules and is configurable. In addition, digital assistants contain built-in intents to handle help, exit requests, and unresolved intents. Digital assistants have built-in and configurable disambiguation messages and prompts that appear when the user's input matches more than one skill. Digital assistants also support non-sequitur routing, which is the ability to handle situations when a user changes the topic in a conversation. For example, if a customer initiates an order, but then decides to check their account balance before completing the order, the digital assistant can manage the routing from the order to the balance check, and then back to the order. Here are the basic features of Oracle Digital Assistant that support the creation of digital assistants. The skill catalog contains a list of all the skills that are in your Oracle Digital Assistant instance. You can use it to configure a digital assistant with one or many skills. Both explicit and implicit invocation is supported for the routing of messages to skills. A skill is explicitly invoked when the user mentions the skill's invocation name in their input. A skill is implicitly invoked when the user input matches the skill without including a reference to the skill's invocation name. Like individual skills, digital assistants provide a set of insights to show the number of conversations for a digital assistant, as well as for each configured skill. Using the retrainer feature, project members can monitor messages that did not resolve and use them to retrain the system so that next time the message is correctly routed. Digital Assistant provides an utterance tester and a conversation tester. The utterance tester allows developers to test how the messages resolve to a skill and intent. The tester shows the intent confidence within the skill and the confidence in the context of Digital Assistant. This allows the developer to get an idea of whether utterances are overlapping between skills or not. The conversation tester focuses on the user experience when working with a digital assistant. It is possible to test a complete end-to-end conversation for a logical task, which may include non-sequitur navigation. As within skills, conversation tests can be recorded as test cases for frequent replay. Now let's talk about channels. Channels are adapters that convert the Oracle Digital Assistant message format to the format of a third-party Oracle-owned messenger and vice versa. Using channels, a single skill or digital assistant can be used with different messenger types, allowing customers to extend the bot's reach to multiple channels without requiring explicit changes to the bot source code. Oracle Digital Assistant supports several types of channels. User channels available include Facebook, Microsoft Teams, Slack, SMS, Web, iOS, and Android with a native channel, which means that there is nothing needed, except declarative configuration to make Oracle Digital Assistant work with those channels. Agent integration channels connect Oracle Digital Assistant with Oracle B2C Service Cloud and Oracle Fusion Service Cloud so that developers can use a named configuration reference to add human agent support, as well as intelligent advisor and knowledge search to their skill conversations. Applications and events channels enable external applications to initiate a conversation the bot can have with a user. Application channels work on YAML-based dialogues, and events work with the visual flow designer. User channels can be divided into two groups. Native channel types are out-of-the-box channel configurations for specific platforms that handle incoming and outgoing messages with no custom development necessary. In addition, they enable you to update the skills and digital assistants that they are routed to without any downtime. Native channel types are available for messaging platforms such as Microsoft Teams, Slack, SMS, and Facebook Messenger. In addition, there are SDK that enable you to host digital assistants in web, iOS, and Android apps. For platforms that are not supported with native channel types out of the box, you can use the webhook channel type to create a configuration for other messaging platforms. Webhook channels have a standard callback mechanism and are supported by Oracle Digital Assistant's Bots Node SDK. Hands-free, speech-controlled chatbots enable users to talk and listen to a bot. Oracle Digital Assistant supports speech with its own native speech-to-text, text-to-speech conversion, and chat server. The Oracle native speech capability is trained on a rich data set of audio samples to accurately understand spoken messages that are then sent as text to the digital assistant. The Oracle speech functionality is available for the web, iOS, and Android through the Oracle SDK for web, iOS, and Android. In addition, you can create a custom webhook channel to use it with other third-party technologies, such as Alexa, Google Home, and the Twilio Voice API. In summary, Oracle Digital Assistant is a platform that enables you to design unified chatbot solutions consisting of one or more skills, which you can expose through a variety of messaging clients. In this lesson, we talk about the benefits of a good digital assistant and explore the kinds of use cases that best suit digital assistants. We'll start by discussing what makes a conversational digital assistant useful. A truly conversational digital assistant does the following: makes the conversation engaging for its user, works to reduce ambiguity to avoid misunderstanding, guides the user through the turns and expectations of the conversation, employs strategies to deal with falling off the happy path. Conversational AI, such as digital assistants and chatbots, offer a wide range of benefits for both customers and businesses. For customers, one of the primary advantages of conversational AI is that it eliminates the need for a traditional user interface. With conversational AI, users can simply state what they want, whether it's booking time off work or checking an order status, without having to navigate through various web pages or menus. This makes the experience much more intuitive and user-friendly. For businesses, conversational AI can help to streamline customer service processes and reduce the workload on call centers. By automating frequently asked questions, businesses can free up staff to focus on more complex issues while providing faster and more efficient service to their customers. This can be particularly valuable during peak periods when call volumes are high. There are a number of use cases for conversational AI that capture the sweet spot where there are clear benefits for both the customer and the business. For example, businesses can use conversational AI to provide answers to common questions about policies, expenses, and order status. This can be especially helpful for large companies with complex policies or product offerings. Simple high-frequency transactions are another example. Think of things such as entering vacation time on your time card, subscribing to mailing lists, and providing employee feedback. Additionally, conversational AI can be used to gather information from customers before passing them on to a human agent. This can help to speed up the call center process and reduce wait times, while also ensuring that agents have all the information they need to provide the best possible service. Call center support is another area where a conversational digital assistant may help, especially for common types of inquiries that have straightforward answers. In addition, you may use a digital assistant to collect information before getting a human involved. Overall, the benefits of conversational AI are numerous, and the technology is rapidly improving. As businesses continue to explore the potential of conversational AI, we can expect to see more and more innovative use cases emerge, helping to improve customer experiences and streamline business processes. Let's take a closer look at the "Where's my order" example. When a customer is inquiring about the status of an order, a human customer service agent doesn't necessarily provide a lot of extra value. They may not have any more information about the parcel than what they can see in the back-end system. This is where a digital assistant can provide business value. Users can access the digital assistant without waiting and going through a variety of channels. With the digital assistant handling straightforward requests, the agents can focus on escalations and more difficult issues. All of this can lead to greater customer satisfaction. Now let's focus on the vacation request example. Human resources tasks provide some other great use cases, such as booking time off from work. A digital assistant is ideal for such common and simple tasks. It works well conversationally. If you say, "I want to go on vacation on the 29th for 7 days," the digital assistant can quickly book the vacation, taking into account weekends, holidays, and other factors. Using a web app, you would need to find out when the last day is and whether or not it's a weekend or holiday. Overall, using a digital assistant can make the booking process a lot quicker and more straightforward. However, keep in mind that not every business solution is best solved by a chatbot. As the saying goes, if the only tool you have is a hammer, then every problem looks like a nail. We must be mindful of the specific needs of each business and carefully consider which tools and technologies will be most effective in addressing their unique challenges. While conversational AI has a lot of potential benefits, it's important to recognize that not every business problem is best handled with a chatbot. For example, tasks that require filling in a lot of fields, such as tax returns, might be better handled the old-fashioned way with a form. Also, complex interactions that require a lot of back and forth, such as booking a holiday with a travel agent, are not ideal for chatbots. Similarly, engagements that aren't really conversations, such as command line tasks done by power users, don't benefit from a conversational interface. That being said, there are still use cases related to these scenarios where a conversational assistant can be incredibly valuable. For instance, an FAQ bot can be integrated into a web application to help users navigate complex tax forms. Similarly, when planning a family holiday, a bot can be used to provide recommendations on weather, pricing, and other information. Even for power users who may be more comfortable with command line interfaces, there may be cases where using voice commands would be more efficient. And for search, NLP can give more accurate results. It also affords the opportunity to combine FAQ and search approaches. Ultimately, it's important to identify the sweet spot for conversational AI and play to its strengths. There will always be some use cases where it doesn't make sense, but there will also be many situations where it can provide significant value. As technology continues to develop and improve, we can expect to see even more creative and effective ways of incorporating conversational AI into our daily lives. In summary, a conversational digital assistant can be used to handle straightforward user tasks in a way that is pleasing to the user and which potentially can save the business time and money. The key is to find the use cases that fall into the conversational sweet spot. In this lesson, we'll talk about the attributes of a great conversation with a digital assistant. To establish the success of a digital assistant, we need to consider three critical aspects: business benefit, conversational sweet spot, and implementation. Business benefit involves building a solution that offers demonstrable value to the business, such as improving call center efficiency or reducing user load. The conversational sweet spot requires identifying what users want from a conversational assistant that they cannot get from a web app. And don't forget implementation. Delivering a digital assistant with a great conversational use case, but poor implementation can result in disaster. Thus, it is crucial to get all three aspects right for success. As a conversational assistant, it's important to embrace the wonderful things about conversation. Although buttons can be helpful, they shouldn't be the primary form of navigation. Instead, the focus should be on getting the user to say exactly what they want. This means embracing the characteristics of natural conversations, including using human traits such as offering alternative suggestions instead of giving invalid error messages. Remember, a good conversation doesn't happen by accident. It has to be designed. For a conversation to work well, the chatbot needs to understand the user. Well-designed intents and training are crucial. In addition, you need regular testing to ensure that language understanding doesn't degrade. Finally, the user should be in charge. Do not force users to remember specific keywords or paths to make the bot work. The bot should understand the user's requests and offer helpful guidance without forcing the user down paths they don't want to go down. In addition, you need to anticipate where things can get off track, the unhappy path, and design ways to handle this. In summary, to create a conversational assistant that users will love, we should embrace natural conversations, prioritize human traits over robotic ones, design the bot's brand and personality, ensure language understanding is continually improving, and put the user in charge. In this lesson, we'll talk about the high-level steps of creating a digital assistant and how they fit together. Here are the high-level steps. First, you need to understand and agree on the goals of the conversation design project. From there, you should run a conversation design workshop to determine what you want the conversations to look like. Next, you'll start building the NLP model, which will be an iterative process throughout the project. You then build the conversation flows and back-end integration. From there, you'll do user testing, go live with the project, and then continue improving the digital assistant. Let's look at each of these steps in more detail. We'll start with understanding the goals of the conversational project. When embarking on a conversational AI project, it's important to be clear on your goals and what you hope to achieve. Here are some questions to consider. Why are you building a conversational assistant? Is it to provide a more personalized and engaging experience for your users? To increase efficiency and reduce the burden on your support team? To reach users through new channels? How is a conversational assistant better than a web app? Does it offer a more natural and intuitive interface for certain types of interactions? Does it allow for more personalized and contextualized responses? How is it better than search? Does it allow users to quickly find the information they need without having to sift through search results? Are you looking to improve customer satisfaction and experience? If so, how will you measure and track this improvement? What is the sweet spot you are aiming for in terms of the level of automation and human interaction? Will the assistant handle all interactions or just certain types? Are you looking to reduce business load, smooth spikes in business traffic, show innovation, reach users through new channels? You'll want to define your specific objectives in these areas. Next, define use cases and scenarios in which users would interact with the assistant. What types of questions or tasks will it be able to handle? How will it respond to different types of user input? Establish clear measures of success for the project, such as user satisfaction ratings, reduction in support team workload, or increase in conversion rates. It's important to start small and iterate as you learn. Begin with a narrow focus and gradually expand the scope of the assistant based on user feedback and usage data. By answering these questions and defining your goals, use cases, and measures of success, you can set your conversational AI project up for success. The next step is to conduct a conversation design workshop. In a conversation design workshop, the goal is to create a conversational experience that engages users and meets their needs. To start, you need to define the digital assistant's persona, including their tone of voice and language style. You also need to consider how the assistant deals with common conversation challenges, such as help, failure, and misunderstanding. Next, you need to define your user, including their expectations and how you want them to feel during the conversation. Think about how you expect users to act or respond and their level of familiarity with conversational interfaces. When designing the conversation, it's essential to consider both the happy path and the unhappy path. The happy path is the ideal conversation flow, whereas the unhappy path refers to unexpected turns or user errors. You need to design how to handle errors, invalid data, off-topic requests, requests for help, small talk, uncertainty, and user frustration. After creating the initial design, you should test and validate it with real users. You can use Wizard of Oz testing, where a human plays the role of the digital assistant, or table reads where people read and act out the conversation. Finally, you should also validate the design with your target audience to ensure that it meets their needs and expectations. Building an NLP model requires careful planning and attention to detail. The first step is to create a first-cut design by partitioning use cases into skills. Then you further partition those use cases into intents. Identifying where intents can use entities is also crucial, because entities can be used to derive variable information. It's essential to remember that entities should be used to derive variable information, not meaning. Once the design is complete, you build and test the NLP model. The first step is to gather utterances and then curate, clean, augment, and balance them. This process is crucial to ensure that the model can understand and interpret user input accurately. The training data should be split into an 80-20 ratio for training and testing, respectively. This split ensures that the model is adequately trained and that it can generalize well to new data. You then test to make sure that the model holds up. After building and testing the NLP model, it's essential to review, refactor, retrain, and test it continuously. This approach ensures that the model remains viable and can adapt to new scenarios and use cases. In conclusion, building an NLP model requires a comprehensive and iterative approach. Partitioning use cases, identifying intents and entities, and gathering and curating training data are all critical steps. It's also essential to split the data into training and testing sets, prove the viability of the model, and continuously review, refactor, retrain, and test it to ensure its accuracy and effectiveness. With a well-designed and well-tested NLP model, businesses can provide their users with a seamless and intuitive conversational experience. The next stage in the conversational project timeline is building the conversation flow. Before we elaborate on the process of designing flows, it's important to note the role of entity slotting and its potential challenges. Entity slotting can be more complicated than it seems, and it's essential to understand your entity slotting strategies to avoid potential pitfalls. For example, when a user says, "book a table for 8, the system needs to determine whether they mean 8 p.m. or 8 people. Similarly, when a user says, "create a new task for June," the system must determine whether they mean the month of June or a person named June. In the case of "book a flight for my wife and I and 3 children," slotting 3 is not possible, and the system must find a way to handle the request accurately. You need to spend some time understanding and working through entity slotting strategies. This starts with determining how to find, prompt for, and slot entity values. To mitigate the unhappy path in entity slotting, designers must aggressively research and understand where entity slotting can go wrong. They must also use strategies such as validation, auto-disambiguation, synonyms, lock-in, progressive help, and error handling to ensure that the conversation flows correctly. When designing conversation flows, it's essential to modularize and look for reusability to avoid creating duplicate or unnecessary work. Customization through parameters can also help streamline the design process and make it easier to maintain and update conversation flows in the future. Building a conversational experience requires integrating back-end systems to enable seamless interactions and efficient automation. To identify and build back-end integration, businesses must determine which API they need to call and how they are secured. It's crucial to understand the capabilities of the API and the data they provide to ensure that they meet the needs of the conversational experience. To facilitate integration, businesses must build conversation-first facades. These facades act as an intermediary layer between the conversational interface and the back-end system, translating the user's request into the appropriate API call and returning the result in a conversational format. By building these facades, Businesses can simplify integration, improve performance, and reduce the risk of errors or security vulnerabilities. In addition to building the facades, businesses must define their DevOps plan to ensure efficient deployment and management of the conversational experience. They must determine the deployment strategies, such as continuous integration and delivery, to ensure that the system is always up to date and optimized for performance. They must also identify the resources required to support the system, such as server infrastructure, databases, and monitoring tools, and ensure that they are deployed in a secure and scalable manner. Don't forget about testing. User testing is a critical component of building a successful conversational experience, especially in the areas of NLP and conversation flow. To ensure the NLP model is accurate and effective, businesses should build NLP tests using the 80-20 split data and different types of test suites. These test suites should include functional tests to ensure the model is functioning correctly, regression tests to ensure new updates do not introduce new issues, and performance tests to measure the speed and efficiency of the model. Businesses should also harvest new quality testing from real users and real logs to improve the model over time. When it comes to testing conversation flows, businesses must ensure that the tests are repeatable, investigating where users typically fail or escalate in the process. Be sure to make time for user acceptance testing. User acceptance testing is critical to ensure the digital assistant meets the user's needs. Businesses must ensure that the digital assistant has a personality that engages users, is helpful and empathetic, and uses natural language. When conducting user acceptance testing, businesses should look for common red flags, including user escalation, frustration, and common phrases that are unresolved, such as yes, no, and thanks. Overall, user testing is an essential component of building a successful conversational experience. It allows businesses to improve the accuracy and effectiveness of the NLP model, test conversation flows, and ensure the digital assistant meets the user's needs. By incorporating various test suites, harvesting quality testing from real users, and conducting user acceptance testing, businesses can continually improve the conversational experience, meeting user expectations, and driving business success. When you go live with a digital assistant, your work isn't done. It's essential to be pragmatic and realize that the first day is likely to be the worst day. Businesses should have a backup strategy for switching off the digital assistant if necessary. In addition, they should also have clear development, testing, and production instances and processes in place. By having these processes and strategies in place, businesses can ensure a smooth transition to go live and mitigate any issues that may arise. After the digital assistant is live, it's crucial to care and feed it continually. This starts with monitoring the digital assistant. You should periodically go through the conversation logs to identify any failures in the NLP, new use cases, and key alarm points. These alarm points might include swearing, frustration, requests to speak to a human, or repeating locked-in conversations. From there, mine the conversation logs for quality utterances and tests to continually improve the digital assistant's performance. Overall, the process of care and feeding is a rinse and repeat process, meaning it's something that businesses must continually work on to ensure the digital assistant meets user expectations and drives business success. By monitoring, identifying, and continually improving the digital assistant's performance, businesses can ensure a positive user experience and long-term success. A good digital assistant is like a living being. To make it successful, besides the nuts and bolts implementation, you need to do a lot of planning and design work at the beginning and care and feeding after the project goes live. In this lesson, we'll talk about the competencies that your team needs to make a conversational project successful. Every skill you acquire doubles your chances of success. This is a list of the key roles we see in a conversational AI project. That does not mean we need 8 people, each one representing a role. In practice, there will be roles owned by the same person. Let's go through the roles one by one. We'll start with the business owner. For a business owner in a conversational AI project, there are several key responsibilities that must be taken on to ensure the success of the project. The business owner must First, define the use cases, goals, and measures of success for the conversational AI system, outlining what it is intended to be achieved and how its effectiveness will be measured. Have a strong understanding of the domain and users to ensure the conversational AI system meets the needs of users and the domain. Work closely with the conversation designer and champion to define the conversational experience and conversational strategies. Be responsible for overseeing the data manufacturing and NLP training, working closely with an NLP specialist to define the domain of the model and review data manufacturing jobs. The business owner also needs to understand where the bar should be set for conversational experiences and acts as a project manager to define and oversee the process for quality and governance. This involves overseeing data, testing, and conversational experience to ensure that the system is delivering the intended results and providing a positive user experience. With these key responsibilities in mind, the business owner can take an active role in ensuring the success of the conversational AI project. Now we'll move on to the conversation designer. The conversation designer plays a key role in maximizing the impact of a conversational project and acts as a champion for conversational values. It is up to the conversation designer to champion and drive conversational excellence, and continuously push the bar higher on all conversational aspects of the project. The conversational designer brings new ideas and strategies to the table and always asks, "Could we do this?" In addition, the conversation designer runs the conversation design workshops. In these workshops, the designer works closely with the business owner to advise on conversational best practices, steering them to the conversational sweet spot, validating use cases and decisions, and teasing out the problem areas for the agreed strategies. The conversation designer is responsible for documenting the conversational experience lies and ensuring the conversational experience is top-notch, including conversation flow, persona, tone of voice, error handling, help, recovery, fallback, and discovery strategies. The designer also runs early testing and validation to catch any issues before go live. Working closely with the NLP champion, the conversation designer develops disambiguation strategies to ensure the best possible understanding of user intent. Additionally, the designer works on writing bot responses that are engaging, helpful, and empathetic. The role of data manufacturing and model training is crucial in building a successful conversational AI project. The person responsible for this role is responsible for the viability of the NLP model, including designing intents, serving as a gatekeeper for the process of creating quality utterances process, and implementing and overseeing measures for quality and success of the model. This person works closely with the business owner to validate and rationalize NLP based on the business domain and ensures that the use case decisions work for the NLP. They also work with the conversation champion design on disambiguation and fail strategies to create a smooth conversational flow. One of the important tasks of the person responsible for data manufacturing and model training is to harvest quality utterances. This involves setting up data manufacturing jobs with high-quality guidance and questions, validating, cleaning up, and augmenting utterances, and building test suites to ensure the quality of the model. They are also responsible for the quantitative measure of NLP improvements, which helps to determine the success of the model. By performing these tasks efficiently, the person responsible for data manufacturing and model training plays a critical role in the success of the conversational AI project. And of course, we can't forget about the skill. The skill developer is the one responsible for building the actual skill that the digital assistant will use to interact with users. To be successful in this role, the developer must have a deep understanding of all aspects of digital assistant features and best practices, including intent design, entities, entity event handlers, conversation flow, and custom components. Working closely with the NLP champion, the skill developer trains and refactors the NLP model, ensuring that it is optimized to deliver the best possible user experience. In collaboration with the conversation designer, the skill developer is responsible for implementing conversation flows that include entity extraction, varied prompting, validation, error handling, disambiguation, and other essential features. They must design for reuse and best practices to ensure that the skill can be easily maintained and enhanced over time. Additionally, the skill developer defines development processes related to versioning and deployment, ensuring that changes are properly managed and rolled out without disrupting the user experience. The skill developer works closely with the integration team to ensure that the skill can make calls to the back end as needed. Finally, they advise the business owner and conversation champion on platform features to exploit, helping to ensure that the skill is as effective and efficient as possible. A back-end integration is a crucial component of a conversational AI project that allows the digital assistant to communicate with back-end services and systems. The person responsible for the back-end integration plays a critical role in defining the separation between the Oracle digital assistant and back-end services. This includes identifying the back-end services and API required for the project, and designing and implementing appropriate API facades to enable the digital assistant to communicate with the back-end services. In addition, the back-end integration specialist must also advise on enterprise deployment strategies. This includes making decisions on architecture, security, and DevOps, which are critical components of a successful conversational AI deployment. The back-end integration specialist must ensure that the digital assistant can securely and seamlessly integrate with back-end services without compromising the security or performance of the system. The front-end developer is another critical role on the conversational AI project team. The person in this role is responsible for the channels through which the digital assistant will be accessed. They must have expertise in building channel-specific features and ensure that these channels are seamlessly integrated with the conversational AI system. In addition, the front-end developer should be able to advise on the management and deployment of channels. They should work closely with the ODA developer to ensure that the adaptive channel requirements are met. This includes identifying features that are supported, not supported by the channel, and how they can be exploited to benefit the channel. The front-end developer should also help limit the channel dependencies in ODA code, because this will ensure that changes to the channel don't impact the overall performance of the conversational AI system. They should work closely with the rest of the team to ensure that the channel is fully integrated with the back-end systems and the conversational AI engine. This includes identifying and resolving any issues that arise during development, testing, and deployment of the channels. Testing is a critical component in ensuring the overall quality of a conversational AI project. The testing team is responsible for ensuring that the skill is functioning as intended and meeting the business goals. They work closely with the conversation designer and the NLP champion to carry out early-stage testing, including Wizard of Oz testing. They are responsible for validating the quality of tests and ensuring that they are being run on a periodic basis to catch any issues early on. In addition to early-stage testing, the testing team also carries out customer and acceptance testing to ensure that the skill is meeting user expectations and business goals. They work with the care and feeding team to identify areas of improvement and take action to implement necessary changes. The testing team gathers and reviews the history of tests, using this data to identify trends and areas that require further attention. Overall, the testing team plays a vital role in ensuring that the skill is meeting the quality standards and goals of the project. The people in charge of care and feeding are crucial to ensure the continuous improvement of the digital assistant after go live. One of the primary responsibilities for people in this role is to regularly review the conversation logs to identify any failures or areas for improvement. By analyzing the logs, they can determine the effectiveness of the digital assistant and identify new use cases that could benefit the business. From there, they retrain the digital assistant based on what they have learned. To address any identified issues, the care and feeding team works closely with other team members to provide feedback into their areas of expertise. For example, they may work with the business owner to ensure that the digital assistant is meeting business needs and identify new use cases that could be beneficial. They also collaborate with the conversation designer and champion to improve the handling of confusion or ambiguity in conversations. Additionally, the care and feeding team works closely with the NLP champion to retrain the model based on the analysis of the conversation logs. By doing so, they help to ensure that the digital assistant remains accurate and effective in understanding and responding to user queries. Overall, the care and feeding team plays a critical role in the ongoing success of the digital assistant. Through their analysis of conversation logs and collaboration with other team members, they help to ensure that the digital assistant remains relevant, accurate, and effective in meeting the needs of the business and its users. To complete a successful conversational project, you need people serving many of the typical roles of a software project, like front-end and back-end development. But you also need people who focus on less traditional aspects, such as conversational design and active care and feeding of the digital assistant after it has gone live. In this lesson, we'll define conversation design and discuss the work and responsibilities of the conversation designer. Conversation design is the practice of making AI assistants more helpful and natural when they talk to humans. So, what is it that makes a great conversation anyway? In conversational AI, a good conversation is one that feels natural, collaborative, and personable. It should be concise and relevant, and it should embrace positive human qualities such as empathy, humor, and contrition when appropriate. The conversation should also exhibit traits such as acknowledgement, reciprocity, and comprehension to make the user feel understood and valued. A good conversation should not be repeating or rigid, but should be open and not constrained or restricted. Users should not feel locked into a repeating cycle and should have the ability to move around the conversation topics freely. This can be achieved through the use of context and the ability of the chatbot to understand and respond to the user's needs and intentions. Additionally, a good conversation should not require the user to use specific trigger words or follow a specific script. The chatbot should be able to understand and respond to a wide variety of user inputs and be able to adapt to the user's preferences and needs over time. By focusing on these traits, conversational AI can provide a more engaging and user-friendly experience, leading to greater user satisfaction and adoption. The aim of the conversation designer is to nurture an excellent conversational experience. To achieve this, the designer must fulfill the following key responsibilities. Identify use cases that align with the goals of the organization and its users, and gain a deep understanding of both user and bot needs. Design a persona and overall experience that is engaging, efficient, and effective. As part of this, create happy path flows that guide users to successful outcomes, as well as design and strategize for unhappy path handling to ensure the bot is able to handle unexpected or difficult user requests. Write bot dialogue and responses that are natural, concise, and on brand, and verify the dialogue through rigorous testing to ensure that the bot is delivering a high-quality conversational experience. The conversation designer has to bridge a gap between two different worlds. Humans use natural conversation with human characteristics. They may switch conversation and context, may imply meaning, and are ambiguous and imprecise. Digital assistants, on the other hand, need to be explicitly coded to mimic characteristics of human conversation. They tend to be rigid in the conversation flow, need the user to be explicit, and try to map to a single intent and extract entity values. Defining and taking control of the persona is crucial for the success of a digital assistant. If left undefined, users will project their own expectations onto the assistant, which may not align with your brand's vision. The persona is an extension of your brand and must reflect the brand's identity. When defining the persona, consider whether you want the assistant to be formal or friendly, and what specific traits you want to project, such as trustworthy, financially astute, or cheerful. Moreover, the persona serves as a template for your development team, ensuring consistency across your digital assistant's development. It helps define how the assistant deals with various facets of a conversation, including failures, misunderstandings, escalations, and returning users. By taking control of the persona, you can create a cohesive and effective user experience that aligns with your brand's vision. To make the most of a digital assistant, you need to focus on what makes a conversational experience truly conversational. This means designing the experience to engage with users on their terms while establishing a persona that reflects your brand and business goals. In this lesson, we'll talk about the key aspects of conversation design and provide some examples of each. Here are some key areas to focus on in designing conversational dialogues. Acknowledgement or discourse markers. These confirm that the user has been heard and understood, and provide cues for what the digital assistant expects next. Implicit confirmation, to show what the digital assistant has understood and which helps reduce ambiguity in the conversation. Prompts, which cue the user for what the digital assistant expects next. Choice architecture, which means designing the conversation to guide the user toward making the right choice. This can be done through clear and concise prompts and by offering relevant options that are easy to understand. Jenga technique, which is a technique used to reduce cognitive load in the conversation. It involves taking out unnecessary words or phrases without changing the meaning of the message. This can help to simplify the conversation and make it more user-friendly. Now, let's take a look at some examples of these techniques. For our first example, let's look at how acknowledgement works. As you can see, the bot has responded to the user's request with a simple acknowledgement of the message and a promise to proceed. Now, let's look at implicit confirmation. Implicit confirmation takes acknowledgement a step further. The response isn't just a promise to proceed, but a specific promise to help order a pizza, which implies to the user that the bot understood the request correctly. The next focus area is prompts. In this example, the implicit confirmation is followed up with a prompt asking for pizza size. This helps the bot move the conversation closer to resolution. Now we'll look at an example of choice architecture. In this case, the user is given buttons for convenience. They can still type their choice in, but they may find it quicker to click one of the buttons. Now, let's move on to an illustration of the Jenga technique, where we shorten messages to make them easier to read while keeping the same meaning. Here's a first draft of a message confirming the pizza order. That's a pretty long message. Now here's another attempt at the confirmation, with inessential information stripped out of the message. To sum up, it's important to make use of techniques such as acknowledgement, implicit confirmation, prompts, choice architecture, and Jenga to make your bot's responses more effective at moving the conversation along. In this lesson, we'll talk about common challenges that a conversation designer faces and ways to overcome them. There are a number of challenges that face conversation designers that they need to learn how to handle. Here are 5 of the most common ones. When users share too much information, it can be overwhelming and hard to process. Dealing with ambiguity requires careful consideration and tactful responses. The user's language may be imprecise or hard to understand, requiring the conversation designer to offer guidance. Better guidance can help users give the right information while also managing their expectations. Sometimes users may expect the meaning to be inferred or implied, even when they don't provide explicit answers. Understanding contextual cues and relevant information can help steer the conversation in the right direction. Ensuring the persona shines through is crucial, as it helps to establish the tone and voice of the chatbot, providing consistency and familiarity for the user. Nurturing and encouraging the persona throughout the conversation can help to build rapport and trust. Let's take a look at some examples of how to deal with these challenges. It's pretty natural in human conversation to provide a long description of a situation without initially being clear about what the primary problem is. A bot needs to do its best to parse through this information to come up with an appropriate response. But trying to pick out one thing might not be the best approach. In this example, the bot tries to deal with the same response by providing some options to help move the conversation along in the right direction. Another potential hurdle is when the user's language is not precise. Here's an example where it's not clear if the expense is for 2 or 3 people. The bot sees the number 2 and responds to that and is probably incorrect. Here's an improvement on the previous response, which guides the user to properly account for everybody covered in the expense. In this example, the user has implied that they indeed are ready to confirm that order by saying that they'll pay with MasterCard. However, this bot doesn't make that connection. Ideally, it would. In a conversation, a user might provide information that is relevant to other parts of the conversation. However, this bot doesn't make the connection that the first question relates to the second question, that is, that they want to pick up their meds in Dolly City. In this example, the bot is successful in associating the context of the first user message with the second. Finally, let's look at how persona affects a message. In this example, the bot responds in an inflexible way that demands that the user respond in a precise manner to a question that they might not clearly understand. And here's a way to handle the same situation in a more forthcoming manner that takes into account that in real life it might not be so clear where to find the order number. In summary, there are a number of common challenges in conversation design that you should learn to handle. These challenges include long, ambiguous, and imprecise messages, handling contextual awareness, and designing the conversations so that they reflect the persona you envision for it. Welcome to the Design and Build Intents and Entities module of this course. In this lesson, we'll take an introductory look at NLP, which is the foundation for creating chatbots that understand what a user is trying to express. In the context of NLP, natural language processing, words are often encoded into numerical representations in order to be processed by machine learning models. There are various methods for encoding words, but one popular method is the use of word embeddings, which represent words as high-dimensional vectors. Tokenization is the process of breaking down a text into smaller units, typically words or subwords, which are called tokens. Here's an example of tokenization for the sentences "I love my dog" and "I love my cat." As you can see, the tokenization process has split each sentence into its constituent words and removed any punctuation or other non-word characters. The resulting outputs are lists of tokens, where each element corresponds to a word in the original sentence. Ambiguity is a fundamental challenge in natural language processing, which can arise when the meaning of a sentence is unclear. For instance, the sentence "I love my club" is ambiguous and could refer to a golf club, a sports club, or a sandwich club. This ambiguity can be resolved with additional context, such as in the sentence "I love my chicken club," where the specific type of club is mentioned. Nonetheless, disambiguating natural language text remains a difficult challenge in NLP. Each phrase can be represented as a multidimensional vector that captures its meaning and context. This enables natural language processing platforms like Oracle Digital Assistant to use pre-trained models and make assumptions beyond the training data, allowing the system to understand and respond to user input even if it is not part of the training data. For example, if a user expresses a positive sentiment by saying "I love my Labrador," the model can interpret the sentiment and understand the context of the sentence, even if Labrador was not specifically part of the training data. This ability to make accurate inferences based on context is a key advantage of pre-trained NLP models, which can significantly improve the accuracy and usability of conversational AI systems. This lesson went over the basics of how natural language processing works. In the following lessons, you will learn to apply NLP to the creation of robust training models. In this lesson, we'll look at designing intents and partitioning between those intents. Just as cars and databases are intentionally designed to meet specific needs, intents in natural language processing systems should also be deliberately designed. By carefully designing intents, natural language processing systems can better understand user input and provide more accurate responses. This also makes maintenance of the skill easier, and this also improves digital assistant routing. Designing effective intents is crucial in natural language processing, and each intent should be as linguistically distinct as possible to ensure the model can accurately distinguish between them. A good way to approach this is to focus on what makes each intent unique, mapping them to specific use cases to ensure a clear focus and purpose. Utterances define intents, and it's essential to consider different ways of stating an intent to ensure the model can recognize it in various forms. To build a good NLP model, it's critical to have well-defined and distinct intents that map to specific use cases. This involves identifying what makes each intent unique, with a singular linguistic focus as much as possible. What goes into making a good NLP model? Here are the most important things. The intents need to be well-defined, and each intent should have a clear focus and purpose. Each intent should also have as singular of a linguistic focus as possible. When creating intents, actively think about what makes the intent unique. Keep in mind that there are distinct ways to express an intent. By considering different ways to state each intent, such as "please reset password" versus "I can't log into my account" versus "my password got hacked," then the model can more accurately classify input and respond accordingly. It's also important to remember that natural language processing is a classification problem, not an understanding problem, and the model is trained to classify input based on the assigned intent. By designing intents with these principles in mind, you can create a more effective and accurate natural language processing model. Early on in your efforts to partition your intents, it's important to test your model, see how it copes. If you don't, then it's all just guesswork. As any problems arise in the model, always be willing to refactor intents. For example, dividing single intents into multiple intents allows you to craft distinct responses to similar but differing questions. There are no hard and fast rules, but 2 intents are probably too few, while 500 intents per skill are probably too many. Consider using multiple skills and a digital assistant. Ideally, each skill should have a common linguistic theme. Now let's take a look at a pair of intents that are not well partitioned. As you can see, there's a book vacation me intent and a book vacation other intent. The purpose of the first of these is to book vacation for oneself, while the second one is for booking vacation for someone else. You'll notice that the intents are linguistically very close. In this case, an entity is used to derive whether the intent is for me or for someone else. However, using entities to derive meaning with trigger words is a potential point of failure. If the user doesn't use me as expected or me is used a different way in the sentence, the intent resolution might be incorrect. You don't need to use such tricks with entities to get the meaning right. The model can be smart if it is well designed and trained. Properly trained, the model can easily distinguish between the intents. NLP should do the heavy lifting. So how do you build a good NLP model? Your NLP model, just like cars or databases, must be designed. It can't be thrown together or rely on some kind of AI magic. The first thing to think about is how to partition your skills. It helps the development process if you can split the development into separate functional skills. However, there is also another consideration, and that is linguistic partitioning. Ideally, you should be considering each skill to have a common linguistic theme, and this should ideally be distinct from each and every other skill in your digital assistant. Let's consider the example of an HR skill. Now we might have a single HR skill, which deals with holiday requests, tax questions, pay, benefits, and more. Arguably, these are all under the common umbrella of a single HR skill. However, let's consider if this skill is part of a digital assistant. What is the signal of this skill? Well, of course, you and I could say it's all about HR, but the DA doesn't know what HR is. All it sees is this quite broad set of use cases for which it's going to have to generalize to try and route requests. Now, let's spend a few words on unresolved intent. Just like we train the model to understand things it should understand, we can train it to acknowledge things that it doesn't understand. Digital Assistant will automatically generate an intent called unresolved intent, which represents an out-of-domain model. In other words, what the skill doesn't cover. The in-domain model of a skill is determined by the theme of utterances that are in its training model. For example, a skill that handles banking tasks doesn't take pizza orders. Typically, you don't need to create training utterances for unresolved intent. In some cases, you may need to create training utterances for a skill's unresolved intent to keep a digital assistant from responding to a certain type of utterance, but this isn't the norm. In this lesson, we covered the principles behind good intent design and how good intent partitioning and skill partitioning will make a digital assistant work better. We also touched on unresolved intent and how it enhances the model. In this lesson, we'll take a conceptual look at how NLP works and what goes into a good training model for a skill's intents. Much of the NLP model is a black box and non-deterministic, but let's look at the broad concept and see what we can learn from it. At its core, NLP is a classification task. Your goal is to come up with a well-formed model. To start with, this means having clearly defined intents, and the borders to those intents shouldn't overlap. If the model isn't well-formed, you may have overlapping intents. This makes it difficult for the NLP to properly classify utterances, especially those in the overlapping area. This results in the need to disambiguate more often, usually by asking users to clarify their intent. Another extreme is creating a set of utterances that is formulaic and overfitting. This is caused by lack of variation in the training data and may result from not having enough different people providing training utterances. Such lack of variation does not reflect real-life user input, and as illustrated, any input with the slightest variation could fail to resolve to the intent. Another anti-pattern is what we call big bucket intents. Big bucket intents are those where we try to handle related but distinct types of requests with one intent. For example, imagine a pizza intent where we accept order pizza and cancel pizza as utterances. In an attempt to get this to work, one might rely on entity slotting to derive meaning, but that is bad practice with its own pitfalls. In any case, you shouldn't need to try such tricks. The NLP is smart enough that you don't need to create such generic intents. And the more generic the intent is, the more generic the NLP classification is, and thus the less useful the skill is. To conclude this discussion, let's look at a plot of utterances for a production skill. This is a two-dimensional representation of all the utterances for the skill. The visualization helps in understanding how well-formed the model is. This example demonstrates many of the characteristics of a good model. You can see that there are well-defined clusters of utterances with largely clear borders between the clusters. There are a few outliers, which is realistically to be expected, but they are kept to a minimum. In this lesson, we looked at the topic of NLP classification and how to create utterances so that they do a good job of reflecting distinct intents. In this lesson, we'll focus on how to create a robust set of training utterances for your skill. There are three general principles to keep in mind when you are designing utterances. First of all, you want to make sure that the utterances convey the uniqueness and distinctness of the intent. You then want to ensure that there is natural variance among utterances for the intent. Third, you generally should have grammatically complete and correct sentences. Let's take a moment to elaborate on each of these principles. When you start writing utterances, focus on the core purpose of the intent, or what you might think of as its sweet spot, and make sure you understand the boundaries and limits of the intent. As you continue writing utterances, vary the structure of the phrasing and the focus of the phrases. In addition, use variations on key terms to help give context on the meaning of those terms. You'll also want to think of different types of sentences that can be used to express the intent. The reason you want to use complete and correct sentences is that the model learns from the context of a sentence. For example, the utterance "I need to check my bank balance" makes it clear that bank refers to a financial institution, not, for example, a river bank. Also, you don't need to risk distorting the training model by including utterances with typos or spelling mistakes. Digital Assistant's underlying model is generally sophisticated enough to handle them. With these principles in mind, here is some more useful guidance. Use real-world data as your source for building utterances. It's important to train the model with sentences that users actually say, rather than just combinations of words that express the intent but which real users wouldn't say. Once you have collected enough utterances, augment, clean, and refine them. And be ready to refactor the utterances for your intents as you collect more of them. And here are some important practical rules to keep in mind. Quality of utterances always trumps quantity. Generally speaking, start off with 30 to 40 utterances per intent, but make sure you have at least 80 to 100 per intent once you go to production. When you collect your utterances, use 80% of them to train your intents and randomly set aside 20% of them to test your model. Test early and often to make sure your intent design is viable. And here's some more advice. Don't unintentionally skew results with words and phrases that are not essential to expressing the intent. For example, if one intent consistently uses please, that can skew results if the user says please in relation to a different intent. Also be careful when using entity values within utterances, as they can inadvertently skew intent resolution if they are heavily used in one intent, but not in another. Keep the number of utterances roughly balanced between intents. For example, you wouldn't want one intent to have 300 utterances and another to have only 15. And once again, we want to emphasize that you need to regularly test. You should create and run batch tests to ensure new utterances don't introduce failure. It's also important to keep in mind that Digital Assistant's underlying model does more than just compile the words in the training data. The model has additional intelligence. It understands the sentence and not just the individual words. In the example below, you can see that the Digital Assistant doesn't understand balance my check in the same way it understands check my balance. The model generates variations of utterances behind the scenes and is pre-trained with a general knowledge of English. For example, if it's trained with utterances that include Audi, BMW, and Volkswagen, it may also resolve Mercedes, even if it is not specifically trained with that word. Or if it's trained with taxi, Uber, and Lyft, it may also be able to resolve cab. To activate this aspect of the model's intelligence, you need to include the context of the words in your training data. For example, the word bank has several meanings. If you want to use the financial institution meaning of that word, they include training utterances that provide that context, like, I need to check my bank account balance. There are 3 general approaches for creating utterances. You can create utterances manually. This has a couple of key advantages. First of all, you can get started quickly writing utterances yourself and doing initial testing on your model without relying on any other people or tools. And when you are manually creating utterances, it's easier to apply best practices. However, you should not rely on just one person for utterance creation, as that could skew the model toward one person's way of expression. Another approach is to use digital assistant's data manufacturing feature to crowdsource utterances. This is a good way to get multiple people involved and thus create a richer set of utterances. But keep in mind that the quality of the generated utterances largely depends on how well the jobs are set up and the fit of the people doing the jobs. For example, a job for phrases for scheduling meetings should be done by people who at least periodically have to schedule meetings as part of their day-to-day work. Also, after you have harvested utterances from data manufacturing jobs, you will want to curate the results. There are also tools for generating utterances by creating variations on utterances that you provide. However, these tools are not recommended. These tools are not useful for intent creation. The results tend to be formulaic and overfitted. In any case, Digital Assistant's Trainer TM essentially does this in the background anyway when it creates the training model for your skills based on the utterances you have provided, so these tools provide no real advantage. Manual creation and data manufacturing both have advantages for creating training utterances. So why not bring the best of those 2 approaches together? Here's a mixed approach that combines manual creation with data manufacturing. Start your project with manual creation. This approach doesn't have any potential bottlenecks and thus will help speed up development. Shortly after the start of the project, create some data manufacturing jobs for utterance creation. Once the jobs are completed and the utterances validated, add 80% of them to the intents and set aside 20% for testing. Before production, combine the crowdsourced utterances with the manually created ones. In this lesson, we went over what makes a good set of utterances for intents and discussed approaches for creating them. In subsequent lessons, we'll provide some concrete examples of how to do this. In this lesson, we'll walk through an example that demonstrates a way to quickly and manually create a rich set of utterances. The first step is to come up with a few key phrases. In this example, we're using a password request intent as our example. For the first phrase, let's use I want to reset my password, which directly paraphrases the intent name. For the next phrase, let's use something linguistically different, but which ultimately expresses the same goal. Once you have your key phrases, provide some variations that all use the key words in those phrases. Let's first focus on the utterance, I want to reset my password. Reset and password are key words in that phrase, so create several utterances that include those words. Now, let's duplicate those utterances and change some of the keywords. In this case, we'll just change reset to other words or expressions. And now let's duplicate the column that we just created and create more variations. This time we'll change the sentence's object from password to credentials. Now let's alphabetically sort the phrases we have collected to see what we have. Once again, we'll duplicate the list of phrases. And then we'll make various changes in each duplicated phrase to introduce some natural variants. The key here is to provide real variation and not make formulaic modifications across all of the utterances. And now, let's duplicate some phrases in the second column and replace a key term, in this case the word change, with terms like update, alter, and modify. Now we'll sort the phrases from the previous two columns. Look for any patterns or repetition, and make further adjustments as needed. And then repeat the same process for your other C phrases. That is, if you do not decide to create a completely separate intent for it, but with a mapping to the same flow. In this case, it might make sense to do just that since the linguistic difference between reset my password and I can't log in is so big. In this lesson, we have illustrated a technique of how you can go about manually generating a rich set of utterances for an intent in a relatively short amount of time. In the next lesson, we'll walk you through the process of crowdsourcing utterances with Digital Assistant's data manufacturing feature. In this lesson, we'll take a closer look at using Oracle Digital Assistant's data manufacturing feature, which enables you to crowdsource creation and validation of utterances. First, let me explain what we mean by crowdsourcing. Crowdsourcing is the process of getting input from a range of people on a given topic. In effect, crowdsourcing utterances helps put the theory of good utterances into practice. In Oracle Digital Assistant skills, you can do crowdsourcing with the data manufacturing feature. The data manufacturing feature enables you to create paraphrasing, annotation, and validation jobs for intents and ML entities. When you create a data manufacturing job, a URL that points to a form is created, which you then share with the crowd workers. At the end of each job, you can review the collected data and download it for editing. Before you get started with data manufacturing, you need to define your intents, and you should do so as carefully and thoroughly as possible. Doing so ensures that all use cases are covered to avoid gaps or overlaps in the utterances. Once you have your intents, you create a paraphrasing job. This is the job type for crowdsourcing utterances. After you have collected utterances through a paraphrasing job, you'll then want to validate those utterances. You can do this manually, get CrowdWorks involved with a validation job, or both. This step is important for fine-tuning the utterances and preventing errors. I'd like to pause here to note that you may need to be careful to avoid overwhelming your crowd workers with huge jobs all at once. You may find it more effective to create multiple smaller jobs and distribute them to different people. You create a data manufacturing job within a skill in your Oracle Digital Assistance instance. Here are the key fields. Under Job Type, there are options for paraphrasing, annotation, and validation. To generate utterances, you use the Intent Paraphrasing job type. Under Paraphrases per Intent, select the number of phrases you want users to be prompted per intent. Keep in mind that you don't necessarily need many utterances to start. Under Add Intents, you select the skill's intents that you are collecting utterances for. A job can handle multiple intents. Once you have done the general job configuration, you provide prompts and hints for each intent in the job. To avoid overly similar utterances, it's important to have prompts that express what the user's goal is and possibly additional context, to inspire crowd workers to see themselves in the situation and not merely provide narrow variations on one phrase. In some cases, you may even want to provide multiple prompts per intent to encourage utterances with the same goal, but inspired by a different context or point of view. Once you have created the intent paraphrasing job, a link is generated that you can copy and send to your crowd workers. You can then start monitoring the incoming results. Here's an example of what the user sees after they have accepted a job. Once the job is completed, you can view the results within Digital Assistant or download a CSV file and work with them that way. This has been a brief walkthrough of how to crowdsource utterance creation with Oracle Digital Assistant. In this lesson, we'll discuss the testing of your skill's intent resolution. Let's start off by discussing the benefits of a solid testing strategy. NLP is like multidimensional Jenga. Changing one single utterance could impact multiple intents. By creating suites of tests, you provide a consistent and reproducible baseline to compare against, which is important when you are updating your training data. It also gives you the ability to play with what-if ideas. Over time, Having a consistent set of tests gives you the ability to measure improvements in the digital assistant and judge whether it is getting smarter. To start off, let's talk about batch testing. As mentioned previously, batch testing enables you to establish a baseline for the quality of intent resolution in your skill. You build up the utterances for in-domain batch tests at the same time you write your training utterances. After the utterances are written, randomly sort them and then use 80% as training utterances and 20% for your tests. Aim for a pass rate well above the confidence threshold, but don't insist on a 100% pass rate. It's important to keep in mind that a 100% pass rate is not realistic. There almost always be tests that fail, and you especially don't want to artificially alter your tests to get a perfect pass rate. Now, let's talk a bit about the types of NLP tests that you should create. We'll break these down into positive and negative tests. In positive tests, you are testing whether an utterance resolves to the intent you want it to resolve to. In-domain tests, which we'll discuss in the next slide, are positive tests. In negative tests, you are testing to make sure an utterance doesn't resolve to any of your intents. Negative tests help you tighten the boundaries of understanding for intents. There are several types of negative tests, which we'll cover in the next few slides. Now, let's look at the different types of tests in a little more detail. In-domain tests are the must-have tests in your skill. You use in-domain tests to ensure an utterance resolves to a specific intent. For example, you might use the utterance, "Can I order a pizza?" to test the order pizza intent. For out-of-domain tests, you use utterances that semantically don't belong to the intent but use similar words. For example, take the utterance, "You threw out the pizza," that is totally out of order. Though it has the words order and pizza, it doesn't belong to an order pizza intent. So you'd use that phrase as an out-of-domain test to make sure that it is unresolved. Out-of-scope tests are for things that are relevant to the domain of the skill, but which the skill is not designed to handle. For example, the phrase, "I want to order a new BMW," makes sense for an e-shop in general, but is out of scope for one that is focused on food. You use random tests to make sure random phrases do not resolve to any of your intents. For example, "The cookie cutter cuts cookies" should not lead to a match in a skill creating expense reports. For neighbor tests, you use utterances from another skill in the digital assistant to make sure that they don't resolve to anything in the current skill. This helps ensure that there isn't overlap between your skills. In Oracle Digital Assistant's Utterance Tester, you can define multiple suites of tests within each skill. After you run the test suite, you get detailed results, including passes, failures, failure analysis, and unreliable test cases. The results of each test run are saved, so you can compare the results over time. You can also create test suites at the digital assistant level to see how utterances resolve across all skills. With these tests, you can define the context in which an intent should be resolved. For example, if a digital assistant has banking and insurance skills, you can test how a banking-oriented utterance resolves when the current context of the conversation is the insurance skill. Another advantage of the utterance tester is that any utterance test suites that you create are a part of the skill or digital assistant and are carried forward with each new version you create. Summing up, intent testing is a key part of skill development, and you should make a testing strategy a core part of your plan for developing and maintaining your skills and digital assistants. In this lesson, we introduce entities and explain the role that they play in skills. Humans have a natural ability to understand a conversation and extract all relevant information from it. Let's take a look at an example from a restaurant. A customer places an order for a meal. The waiter is able to understand what the customer is asking for and is able to extract the various parts of key information, including the required action, the food requested, and even identifies missing information. This, the human brain, is the technology behind it, and we need to bring these innate capabilities into our conversational AI platform. How do we do so? First, let's review what we know about conversational AI and introduce a few new concepts. Conversational AI is a discipline of artificial intelligence. It uses a machine learning model as its brain. Based on machine learning, it detects what a user wants. We call this natural language processing, or NLP for short. It also uses machine learning to extract information from what a user said. We call this named entity recognition, or NER for short. Going back to the previous restaurant interaction example, we can map a sequence of steps that allows us to gather all information. I'd like expresses the intent. Fried cod with curry sauce is extracted as an entity value for main course. Salad and French fries are extracted as entity values for sides. And there is no information for drinks. In Oracle Digital Assistant, entities are used to extract information from user messages. Depending on how the user message is entered, entity extraction happens in the context of natural language processing or when users are prompted for input. The conversation flow determines the order in which the user is asked to provide information. Then entities are used to extract information based on patterns, a list of known values and synonyms, and machine learning models. And finally, the extracted information is slotted to the conversation so the user will not be prompted for it again. In this lesson, we introduce entities and explain the role that they play in skills. In this lesson, I'll talk about the different types of entities, their key configuration options, and the basics of extracting their values from user messages. In Digital Assistant, there are two broad categories of entities, system entities and custom entities. The first category is system entities, which are built-in entity types that are provided as part of the platform. They include date, time, number, currency, email, yes, no, person, address, and more. The second category is custom entities. With custom entity types, you have to do some configuration, such as defining the possible values. Custom entity types include value list, regular expression, derived, dynamic, machine learning, and composite bag. System entities are ready to use out of the box, with no configuration required, though some, such as date, time, and currency, have locale settings. Here you can see examples of system entities and some values that they have extracted from an utterance. Here are some of the types of custom entities. Value list entities are lists of values with optional synonyms for each value. Regular expression entities are based on regular expressions and can be used to recognize things like license plate numbers and social security numbers. A composite bag entity consists of one or more entities grouped into a single business object. It can also include items of type string, location, and attachments as bag items. The items are resolved together without you having to write code. Dynamic entities are a type of value list entity that you update at runtime via an Oracle Digital Assistant REST API call. And finally, machine learning entities, or ML entities for short, are another special type of value list entity. ML entities allow the extraction of unknown values, so you don't need to directly define all the values. Instead, you create a dataset that enables the entity to identify the entity values in a user message. Custom entities have configurable properties that control entity behavior and message responses. There are a number of common properties across the various custom entity types, including name, description, and prompts. It's possible to configure an entity to allow input of multiple values. And if you don't allow multiple values, you can configure the entity to prompt for disambiguation. You can also supply your own validation rules. There are also properties that are available just for specific entity types. For example, you define value lists for value list entities. For derived entities, you specify a value prefix or postfix. For value list and value list-based entities, you can use fuzzy match to allow matching of words based on the lexical root. For value list entities and skills that use Digital Assistant's native language support, you can add value translations. For value list entities and dynamic entities, you can use the enumeration range size property to limit the number of entity values that are shown at a time in a menu. Here are a few other things you can do with entity properties. You can define multiple prompts for an entity value, which enables the skill to rephrase a request for a value that the user hasn't correctly provided. This keeps the skill from sounding robotic and enables you to progressively provide more guidance if the user hasn't provided a correct value. You can write your own error messages for when the user provides invalid input. You can augment the entity's default validation, which is based on a list of values or a pattern, by writing your own expression-based validation rules to implement business logic. In this example, the validation rule prevents the user from specifying a delivery time after 10 p.m. For composite bag entities, there are some additional properties that you can use. You can use the out-of-order extraction property to extract entity values if they have not yet been prompted for. You can use the extract with property to enable the extraction of a value for one entity in the composite bag with another entity. For example, you could use this property to handle a composite bag with both delivery address and billing address entities. You can provide an expression for the prompt for value property to specify a condition for when to prompt the user for the entity value. As mentioned before, system entities have no configurable properties. However, you can set properties for them by wrapping them in a composite bag entity. When you do this, the system entity becomes a bag item on which you can configure properties. With this simple approach, you open those system entities to many more options. Here are a few notes on how extraction of entity values works once you have your entities defined. To be able to extract an entity from a user message, the entity must be associated with the intent that gets resolved from the user message. Multiple values can be extracted for a specific entity. All occurrences of an entity's values in a user message are saved in an array. You can access all the values of that array by using Apache free marker expressions. You can use the utterance tester to test user utterances for the entities that get extracted and for how many are found. Within the dialog flow, you can use the resolve entities and resolve composite bag components to resolve entities. If the variable type is an entity, then the entity value gets extracted from the user input. Composite bagged entity type variables can extract multiple values. If the value is not provided in the input, the component prompts for it. This concludes this lesson on the different types of entities and the basics of their usage. In the next lesson, we'll take a deeper dive into some of the challenges of entity extraction. In this lesson, we'll detail best practices for entities, with a particular focus on composite bag entities. Let's start off with composite bag entities. What is a composite bag entity? Let's quickly review. Composite bag entities are used to represent domain objects. This means things like person, order, product, booking, request, etc. Each composite bag is composed of bag items, which can be built-in entities, custom entities, strings, locations, and attachments. All bag items get resolved by a single visual flow designer component, such as resolve composite bag or resolve entities. This saves you from having to write separate dialog flow states for each entity or other bag item. The first rule of composite bag entities is to use them as much as possible. Composite bag is the most versatile and powerful entity type available. It simplifies the dialog design because it can resolve multiple entities together with less dialog states. It allows entity slotting more easily where there is validation and rule dependencies between entities, and it wraps system entities to be able to set properties for them. Let's look at some of these advantages one by one. We'll start with multiple entity extraction, and as an example, we'll use a pizza order intent. A pizza order intent may have size, type, address, date, time, and even more associated entities that all need to have values extracted for the order to be completed. Composite bags allow you to extract all of them together. You only need a single component in the dialog flow to manage this. Now let's look at how you can use some of a composite bag entity's validation features. We can validate the input against the entity type, such as email, URL, or phone number. We can also validate against a custom list of values, regular expression, or a custom rule. Additionally, we can define our own validation error messages. Composite bags also have useful mechanisms for error handling. For failed validations, you should have variation in prompts. It's a best practice to incrementally disclose more information with each prompt. For instance, a prompt of that is not a valid phone number could be followed by the phone number should start with 01, which could then be followed by the phone number should start with 01 and have a total of 8 digits. Well-designed prompts can help the user while maintaining a conversational tone. You can use the maximum prompts to define how many times the user is prompted for input. By setting this property, you ensure that a user doesn't get stuck in an endless loop if they are unable to enter a valid value. You should also define a repair path with a transition to a different dialog state that is followed if the user is unable to enter valid input after the maximum number of prompts. You can use the out-of-order extraction feature to slot entity values that users provide before they are prompted for them. It can be set at the item level. Values are slotted even when the user is not prompted for it, or is prompted for a different entity value. This allows us to solve a very common pattern in natural conversation. Now let's talk about entity event handlers. Composite bags are powerful, but on their own, they may fall short of some of your requirements. For example, they can't be used to implement back-end integration. They also can't be used to implement complex business or validation logic. In addition, they can't reference other composite bags. The good news is that entity event handlers provide a solution to these limitations. By writing an entity event handler that you reference from your composite bag, you can use a programmatic approach to resolving the entities. Here's what you can do with entity event handlers. You can define complex validation for the entities programmatically. With event handlers, you are not limited to the Apache free marker expressions that you otherwise need to use if you are relying solely on the composite bag's declarative support. Using event handlers, you can also reference other bag items. Entity event handlers also enable better back-end integration. You can do back-end checks during entity resolution instead of deferring them to the next dialog step. For example, if a shopping skill needs to do a stock check during entity resolution, instead of doing that at the end, you can manage that through an entity event handler. In addition, entity event handlers provide the flexibility to handle more complex scenarios like building context awareness into the skill. Using an event handler, you can store context that was established earlier in the conversation and use it later to set actions. In the example on the right, you can see that the skill has told the user the location of the nearest warehouse and then is smart enough to know that the user is referring to that location with the word there in the next utterance. We have just discussed best practices with composite bagged entities at length. Now let's look at some other entity-related best practices. We'll start with properties for the date-time entity. Take the following two utterances with the ambiguous date value of Monday. We can define the ambiguity resolution rule for the date-time entity as past, future, or nearest, depending on the purpose of the intent that uses the entity. For example, if the intent concerns making future arrangements, you'll want to set this property to future. The default date format is another option you can set. For value list entities, there are also a couple of things that you should keep in mind. First of all, you should make liberal use of synonyms for the various values when there are multiple ways that a person might express that value. For example, for a pizza size entity, you might have a value of large and synonyms of big, grand, and biggest. Also, where appropriate, be sure to take advantage of value list entities to build menus. If you need to create an entity for something for which you can't enumerate all of the possible values, you should consider using ML entities. ML entities enable you to extract known and unknown values from an almost infinite list of options. You define ML entities by providing a set of training utterances that contain entity values that you annotate as such. That's it for this lesson. As you can see, there is a lot you can do with entities to make your skills work more effectively, and composite bag entities play a central role. Welcome to the Dialog Flows, Custom Components, and Back-End Services module of this course. In this lesson, we'll introduce you to Dialog Flows in Oracle Digital Assistant skills. First of all, let's explain what dialog flows are and what they do. Dialog flows define the narrative of the conversations a digital assistant can have with a user within a skill. The conversation flow is akin to a playbook. It must account for multiple scenarios and be well designed to handle different outcomes. You script the ideal path, often referred to as happy path, and alternative scenarios, sometimes called unhappy paths. When a user engages in a conversation that deviates from the main path or fails to provide enough information, the dialogue flow must be designed to handle these alternative scenarios. The conversation flow typically starts with an intent that needs to be resolved, such as an order pizza intent. The dialogue then progresses through various states or interaction points between the user and the digital assistant. Each state could involve a prompt, message, value list, or other display for the user to respond to. Dialogue flows are the backbone of a digital assistant's conversational capabilities in Oracle Digital Assistant. They are comprised of one or more flows, which are connected through the use of invoke flow calls. These flows are visited in a specific order based on the user's interaction with a skill. Each flow in a dialogue is made up of flow states, which can be thought of as individual steps in the conversation. Each flow state is associated with a configured component, which could be responsible for things like displaying user input prompts, presenting user messages, and executing logical or functional operations, like managing variables. Flow states execute logic and render a user interface. They each consist of a component, properties, and transitions. There are two types of components that can be used in flow states, built-in and custom. The properties can be used to pass information into a component and update variables defined in a flow. Transitions are used to navigate to a predefined next state or conditionally navigate to a next state based on the results of an action. Oracle Digital Assistant comes with the Visual Flow Designer, which is a declarative tool you use to create and modify your flows. With its template-driven approach, state creation is simple and streamlined with configurable components that allow you to quickly and easily define what you want the skill to do. For example, send a message to the user. For component property values, the Flow Designer supports static values and expressions using Apache Free Marker, and you can create variables that can be updated by the component. This allows for highly dynamic, responsive conversational experiences that can adapt to the user's needs in real time. Here's an example of what a flow looks like in the Visual Flow Designer. Each flow has a designated start state, which marks where the flow begins when it is called. After that, it has other flow states. The flow states designate transitions to ensuing states. In the diagram, these transitions are represented by the connecting arrows. The name of the transition is noted above the arrows, for example, next or error. Within each state, you can see the name of the type of component that it uses. This has been a quick introduction to dialogue flows and the Visual Flow Designer in Digital Assistant. In the following few lessons, we'll show you how to use the Visual Flow Designer to create dialogue flows. Welcome to the Dialogue Flows, Custom Components, and Back-End Services module of this course. In this lesson, we'll introduce you to dialogue flows in Oracle Digital Assistant skills. Before we go further, it's important to note that the Visual Flow Designer is just one of two dialogue flow editors in Digital Assistant. There is also an older YAML-based editor. To be able to use the Visual Flow Editor for a given skill, you need to create the skill with the dialogue mode option set to visual. This is the default in the Create Skill dialog. Once the skill has been created, you cannot change the dialogue mode option. While the YAML option is still available, it is no longer recommended due to its code-centric development approach, which is more complex and time-consuming than that of the Visual Flow Editor. In addition, the Visual Flow Editor has important features such as the ability to create multiple and reusable flows, which we'll touch on more in the upcoming slides. In skills developed with the Visual Flow Editor, the main flow is the control center of the overall dialogue flow. It is the starting point for all conversations. It maps intents and other events to flows, allowing for the seamless transition between different conversation paths. It provides the ability to define global variables that persist throughout the user session, allowing for the preservation of important information. And it enables you to pass information to individual flows using input parameters. In the main flow, you define which flows are called when specific events occur. These events include built-in events, such as one that occurs when user input resolves to an answer intent. And they include intent events, which occur when the user input resolves to a given intent. In the previous slide, you may have also noticed a box for end flow action events. You use end flow action events to optionally map the outcome of one flow to another flow. When using end flow action events, here's what you need to know. The main flow is always the last flow in a call hierarchy. The flow's end state always returns an action string. You can use end flow action events for things like displaying an action menu once an intent flow completes. Here are some basics of flows and flow creation. There is no limit in the number of flows that can be created within a skill. The maximum number of states in a flow is 50. You can create subflows to avoid exceeding this limit. When you create flows, you can map them to intents, or you can leave them to be invoked by other flows as a child flow. Flows can call other flows and pass and receive information through input and output parameters. Once you have created a flow, you can go to its configuration tab to create parameters and variables for the flow. Here are some things to know about input parameters and variables. They must have a unique name within the flow. They must have a type, either primitive, complex, or entity. You can set an initial value for them. Input parameters and variable values defined for a flow are reset when exiting the flow. And here's what you should know about output parameters. As with input parameters, they must have a type of primitive, complex, or entity. They are declaratively referenced when ending a flow. Once you have created a flow, here's how you go about adding states to that flow. First, you need to add a start state. With the flow's flow tab selected, right-click the start tile and select Add Start State. To add states after the start state, click the menu in a States tile and select Add State. Once you have clicked Add State, you are shown a gallery of component templates for different types of functionality, such as for displaying a message, setting variables, and invoking a flow. Once you have added a state, you can select its tile in the diagram to see the state's component properties, which you can then configure to determine the state's behavior. It's also worth noting that states can be copied from one flow to another if needed. Each state also has transitions that you can configure. You do so on the Transitions tab of the State's Property Inspector. Transitions determine the next state to visit within a flow. For static navigation, you use Next Transitions. Most states have a next transition defined as a default. For conditional navigation, you can use Action Transitions. A lot of this may seem overwhelming, but it's important to note that not everything needs to be connected or configured right away or in a specific order. For example, one way of doing things might be to first create flows and work on them independently, then connect the flows with each other, and then define global variables. You can then finalize your intent model and define any system and external events, after you can map between the various event types, including intent events and flows, and finally reference global variables from input parameters. Here is some advice for getting started with a dialog flow. Keep in mind that it helps to build dialog flows incrementally. First, select a specific conversation to build, whether it's for filing an expense, checking orders, or something else entirely. It's best if it's fairly specific and self-contained. Then create the intent for this conversation. Then create any entities needed for and inside of the conversation. Once you have the intent and the required entities, you can create a flow that specifies the sequence of steps and responses needed to complete the conversation. And finally, create and call subflows for conversation logic that can be reused from other flows. By building conversation flows incrementally, you can test and refine each component of the conversation independently, helping you identify and fix any issues or errors early in the development process. An important best practice is to build self-contained flows. You should always think in terms of modularity, which means breaking down the conversation flow into smaller, reusable components. To facilitate this, use input parameters and output parameters for communication between a parent and the subflow. To indicate to the parent flow what to do next, you use action strings in a flow's end flow state. This has been a high-level look at designing dialog flows with the Visual Flow Designer. In the next lesson, we'll take a closer look at the components that are used in dialog flows. In this lesson, we'll talk about how components work in dialog flows and introduce you to the different varieties of components. So, what do we mean by component in Oracle Digital Assistant? Components are what we use to render the user interface and perform operations. The Visual Flow Designer provides various configurable built-in components. There are components responsible for rendering the user interface of the conversation, such as for displaying prompts and messages to engage users and guide them through the conversation flow. There are also components for operations, such as authentication, setting variables, invoking and ending flows, branching navigation, integrating human agent support, invoking REST services, and notifying users. Components can be added using templates, which are reusable components that define a state's behavior and content. For some components, there are multiple templates, each geared for a certain type of use. Each state in a dialog flow is based on a component. Each component has properties that you can configure to specify its behavior. These properties are exposed on the property panel in the Visual Flow Designer. They can be set using a fixed value or an expression that points to variables. The values of the input and output parameters of the component can be obtained through variable references. When a flow is exited, the input parameters and variable values defined for the flow are reset. Components also trigger navigation in the dialog flow. A simple move on navigation is handled by the next transition. You can also use actions to navigate based on the outcome of the component. You map the transition targets in each dialog flow state. Let's quickly go over the two high-level types of components. First of all, there is a rich set of built-in user interface and functional components that is provided out of the box. The majority of your states will probably use these components. You can also create your own custom components in JavaScript. Custom components are useful for back-end integration and implementing custom logic. Once created, custom components can be reused elsewhere. From the skilled developer's perspective, there is no difference between using built-in or custom components. Both expose properties for input and output values, and both may expose action transitions to conditionally determine the next navigation target. In the Visual Flow Designer, you use templates for the built-in components when creating states in the dialog flow. Each template is associated with a component that is pre-configured with the necessary properties to implement a given use case. Once a dialog flow state is added to a flow, you can edit its properties declaratively in its property inspector. If a component interacts with variables, the relevant variables need to be mapped to the component's properties. A large portion of the templates are for sending messages to users. Here you can see the menus for the user message category of templates and its display multimedia messages subcategory. Most of these templates are based on a component called the common response component, which has a rich set of possibilities for displaying responses, including multimedia messages, user feedback, and messages that are tailored individually for different channels. There are also components for resolving composite bag entities. These components enable you to prompt users for a set of related information that represents a business object, such as an order, customer, or product. Unlike with simple entities, users can provide information in any order they like. Information provided when prompted for something else will not be reprompted for. One significant advantage of using composite bag entities is that all of the logic for resolving all of the bag items is encapsulated within one dialog flow component. Different component templates expose different properties. Here you can see the properties for the send message template, and here are the properties for the display text message component. A general guideline for engaging conversational assistants is to not prompt for information it already has. To assist with this aim, input components can be configured not to render their user interface in these cases, if the referenced variable already has a value set. If they reference an entity variable, and the value was extracted from the initial user message. When an entity value is extracted from the initial user message, this is called slotting. For slotting to work, the entity must be explicitly associated with the intent. This can be done by configuring the entity as a required or optional input parameter for the associated flow. Here's an example where entity slotting is not used, and here's an example where entity slotting is used. You may ask, if an input component isn't rendered, how does that affect the progression of the dialog flow? Will the flow get stuck? That answer is that even if an input component is not rendered, the dialog flow state still is processed. The dialog flow state needs to be processed to determine the next navigation target. If you would like to completely skip a dialog flow state, you can use a switch component to do so. In a dialog flow, the next step in the conversation is determined by the current state. To configure the state's transition behavior, select the Transitions tab in the Property Inspector. There you can find a Next Transition field and a section for actions. The next transition determines the default navigation. You can also use actions to conditionally navigate based on the component outcome, assuming the component supports actions. Some components come with built-in actions. You can also define your own actions. If the component doesn't return an action, the next transition is followed. If a component has built-in actions, make sure to map transitions for them. Otherwise, the next transition will be followed when those actions are returned. For example, the OAuth account link component has pass, fail, and text received actions that you need to map. And that does it for this lesson. Now that you've learned about working with components and their properties and transitions, you are ready to move on to the next lesson, which is on design practices for dialog flows. In this lesson, we'll go over some things you can do in your dialog flows to make them more effective. One of the first things that you should think about when you are designing a dialog flow is how to break it down into individual flows that you can use as building blocks. For example, say you have intents for ordering a laptop and finding orders. You'll likely have a flow for each intent. You may also decide to use subflows for certain segments of the conversation, such as entering personal details. You can then invoke those subflows from the primary flows to handle that part of the conversation, and then return control back to the primary flow once the subflow is finished. Where those conversation segments are the same in different flows, you can use same subflows. You may find yourself asking how many flows you need. The answer is to not worry about the number of flows. There is no upper or lower limit. The key is to determine which flows you need to best serve your design. Here are descriptions of the types of flows you'll need. Intent flows are mapped to one or many intents and control the flow for the task to accomplish. Services flows, on the other hand, provide reusable functionality but are not aware of the user task. Global flows map to built-in events and provide a way to handle system-level events that are not tied to any specific intent or task. Here's an example of a dialog flow architecture for a skill with 4 regular intents. For each of these intents, you have one intent flow. Then you have a group of service flows. These flows are called by the intent flows to handle a part of the conversation. Many of these service flows are used by multiple intent flows. And finally, you have global flows for error handling, authentication, and answer intents. These flows are triggered by built-in system events for system errors, required authentication, and answer intents. When designing conversation flows, it's best to keep them small and simple, focusing on a single conversational task. This makes them easier to read and understand, and also helps copywriters to locate the right messages and prompts. If a flow becomes too large, it's worth reviewing it to see if parts of it could be moved into their own service flow. This helps to keep the main flow focused on the primary task and makes the entire system more modular. Composite bag entities can be particularly useful when interacting with users for a given piece of information. They provide a single state that allows for multi-turn conversations, which can help to skip prompts if users provide information out of order. In any case, the key is to build flows that focus on a single conversational task. This has the added advantages of making it easier for copywriters to find the right messages and prompts, and making sure that change requests, such as those made by UX designers, do not impact other functionality. Modular development can sometimes result in too many prompts and messages being displayed to the user. Unfortunately, this typically only becomes apparent after the flows have been orchestrated into a conversation. To address this, it helps to use the concepts of intent flows and service flows to help differentiate between contextual and functional messages. In general, intent flows should focus on providing contextual messages that help the user understand the purpose and progress of the conversation. For example, you might say, "I placed that order for you," or "To cancel this order, I need you to sign in. Are you ready?" On the other hand, service flows should focus on providing functional messages that help users do things like clarify requests and fill in necessary details so that they can accomplish their task. Here are some examples. By separating these types of messages, we can create a more streamlined and effective conversation that doesn't overwhelm the user with too many prompts and messages. Now let's talk about the life cycle of each subflow. When a subflow is called, another level in the call hierarchy is generated. Eventually, that subflow will come to an end. When it does, values that have been set in the course of the subflow may need to be returned to the calling flow. When you end a flow, the end flow state returns control to the parent flow. There are two ways to end flows: implicitly and explicitly. Implicit end flows don't need to be added to a flow as a separate state, since they only return control to the parent. They do not return any values or an action string. Explicit end flows, on the other hand, are added as a component state. They may return values using output parameters. They also return an action string to the parent flow that could be used to determine the next state to navigate to. Here's an example of how you can use explicit end flows in a child flow to determine the navigation in the parent flow once control is returned there. First of all, let's look at the end of the child flow, which was invoked using an invoke flow component from a parent flow. This child flow has end flow components for three possible conclusions of the flow. Each of the end flow states defines an action string. In the invoke flow state in the parent flow, actions are defined for each of these action strings, and each is mapped to separate state. Here you can see what that branching looks like in the dialog flow diagram. Now let's talk about how the keep turn property works with end flows. In general, this property controls the transition behavior when the state ends. If set to true, the next state is executed directly after the flow ends. If set to false, the skill waits for a user input before the next state executes. It's important to note that any value you have set for this property is ignored and set to true in the following cases: if the current running flow is a child flow, if the current running flow is a root flow, and the last state before the end flow captures user input. By default, the value is set to not defined, and it's recommended not to change this value. That's it for this lesson, where we have discussed design approaches to use when designing flows. In the next lesson, we'll cover testing of conversation flows. Now that you know something about creating flows, it's time to look at how to test them to make sure they behave how you intend them to. Intent resolution is only one part of conversation testing. You also need to verify the conversation continues to flow well and works as expected over time. This involves addressing the following questions. Does the skill still give the expected answer? Does the entity resolution flow continue to work correctly? Are the prompts and messages still correct? Do the correct disambiguation dialogues still appear? Are errors still being handled correctly? To verify that those things are all working as expected, you can use the skill conversation tester. With the conversation tester, you can record conversations and then later play them back to make sure that the skill still responds in the same way as when the test was recorded. If the skill responds differently in the test run, a failure will be recorded. Using this tester, you can verify that answers, entity gathering, prompts, disambiguation, and error handling all work as expected. That said, the conversation tester does have practical limits, particularly that one anomaly early in the test conversation will fail the whole test. Despite the conversation tester's practical limitations, it can still be useful. But you'll want to keep the following things in mind. First of all, you'll want to keep your conversation tests relatively short, as there is only one pass or fail for the entire test. Also be aware of the fact that tests might fail if you have randomized prompts or variations on answers. You can get around this limitation by configuring the test to ignore these strings. As we have illustrated in this lesson, the conversation tester gives you a useful way to verify that the conversation flows continue to work as expected over time. In this lesson, we cover some best practices for creating robust dialogue flows that are easy to maintain and which continue to work well over time. Though it may seem like a minor thing, having a good naming convention is invaluable for development and maintenance of skills. You should use a naming convention to indicate context, meaning, and relationships between artifacts, such as intents and flows. A consistent naming convention makes it easy to filter intent names more efficiently at design time and runtime. It helps copywriters and conversation designers to locate strings and conversation states. It also assists developers with finding bugs and problem areas in the flow design. Here's an example of a useful naming convention. For regular intents, you could have a standard prefix of reg so that someone looking at the skill could see at a glance that it is a regular intent. Then you could standardize segment names to group intents of the same subject areas together, like orders and profile. And from there you could use unique words to specify the action in the subject area, such as create, find, or find.mine. Similarly, for answer intents, you could use the prefix ans, and then standardize segment names for high-level domain and lower-level domains, and then use unique segment names for the questions. For flows, you can use a similar approach, but distinguish between the types of flows in the first segment. For intent flows, you use the intent name but prefix it with the word intent. For service flows, you could use the prefix service, and then a descriptive name for the service flow. For global flows, simply use global as a prefix. For entities, indicate the type of entity with the prefix. For example, for composite bag entities, use CBE. For entity event handlers, it's a good idea to use the name of its associated composite bag entity in its name. For resource bundle keys, it's helpful to prefix the name with the location of where the string appears. For example, for a string in a dialog flow, you would prefix the key name with the name of the flow and the name of the state. For single entities, you would prefix the entity name. For composite bag entities, you could start with the entity name and then the name of the bag item. And for entity event handlers, you could use EEH and the event handler name as prefixes. Now let's switch to the subject of error handling. You should always implement a high-level error handling strategy. This means having a plan for doing things like printing customized messages when errors occur, logging errors, notifying the appropriate admins, and initializing or resetting relevant variables. Particularly where you have complex flows, you may want to implement error handling at the flow level. And as a fallback, you should always define a global error handler in the main flow. That way, if an error occurs in a flow where there isn't an event handler for that flow, the global error handler will handle it. For flow-specific error handling, you can define a special flow and then map to it from the dialog error system transition. For global error handling, you also define a flow, and then you map to it from the main flow's dialog error event. One last area to cover in this lesson is the built-in validator, which can be used to catch problems in the dialog flow, as well as other parts of the skill, including in its intents and entities. Not only does the validator catch errors, but it also provides useful warnings and tips. It's effectively a built-in guide to best practices. You should use it regularly to identify things that are missing from your implementation or which might be done in a more robust way. By using good naming conventions, using error handlers, and taking advantage of the built-in validator, you can make your dialog flows work better and make them easier to maintain. In this lesson, we'll introduce the answer intents feature, which is a low-effort and effective way to implement FAQ and easily provide static answers to other requests. Answering frequently asked questions is a common requirement for digital assistants. To handle this in Oracle Digital Assistant, you use answer intents. Answer intents are like regular intents in that they use utterances to train the NLP model, but they resolve to predefined static answers. The answers are saved in resource bundles, which simplifies creation of multilingual FAQ. For answer intents, you don't need to use the dialog flow at all. However, you can use a flow or multiple flows to enhance the user experience. For example, you can add a follow-up prompt or a feedback component. Here's a quick illustration of how answer intents work at runtime. Imagine you have two answer intents, one for questions about opening hours and another about return policy. Here's what happens when a user asks, "When are you open?" The question is resolved as the Hensidet stores .OpenTime's intent by the intent engine. The system then references the resource bundle entry associated with that intent. It then displays the response to the user question. Here are some guidelines for creating high-quality answer intents. Make sure the model is well trained for each question. Like other intents, This means using 80 to 100 sample utterances for each question with a focus on how users would really ask that question. Be sure to use synonyms and different sentence structures in those utterances. And make sure to set aside some of the utterances for tests. You'll also want to curate all of the answers. Avoid just copying them from a website. Ensure that they are conversational and use the same persona you defined for your digital assistant to establish their voice and tone. Also, consider using answer intents for in-domain features that the skill doesn't support. This means using answer intents as a placeholder for skill features that are missing because there hasn't yet been or won't be time to support them. Answer intents can be implemented with relatively little time and effort, and they provide a way to give users at least some guidance in the absence of corresponding regular intents. Answer intents are a time-effective way to support FAQ in your skill, as well to provide static answers to requests that can't be supported more fully in the skill. In the previous lesson, we introduced and outlined the basic use of answer intents. In this lesson, we'll go over ways that you can use flows to customize the display of answer intents. If you don't use flows for answer intents, a resolved answer intent merely results in the display of the answer and nothing else. If you use a flow or flows for answer intents, you can do more. Here are some of the ways you can customize the answer intent response by using a flow. You can change the way the answers are displayed. For example, you can display the question before the answer to create context and clarity. You can take into account application or user context in the response. For example, you can answer a question about opening hours based on a location. You can also engage with users in a number of ways. For example, you can ask users for feedback. You can display related questions and answers, for example, in a carousel of cards. Or you can simply encourage users to ask another question after the previous one has been answered. Here's what you need to know about displaying answer intent answers using a flow. You can create a flow and have it handle any otherwise unmapped answer intents. You do this by creating a mapping in the main flow between the flow and the built-in answer intent event. In your answer intent flow, you can use the display intent answer component, which is pre-configured to display the answer without requiring any coding. When you use such a flow for answer intents, it displays the same answer as it would without a flow. But using a flow gives you the ability to add dialog flow states before and after answer is displayed. For example, you can prompt for additional information or navigate to a follow-up conversation. In the previous lesson, we illustrated how answer intents can be displayed without a flow. Here's a quick illustration of how answer intents work when a flow is involved. As before, imagine you have two answer intents, one for questions about opening hours and another about return policy. Here's what happens when a user asks, "When are you open?" The question is resolved as the ands stores that open times intent by the intent engine. The intent engine then references the resource bundle entry associated with that intent. The intent engine then passes the resource bundle entry to the flow that is invoked by the answer intent event. The flow then displays the response to the user question. Now, let's look at how you can display the question before the answer in the answer intent response. One reason to do this is to add context to the answer so that users can verify that the question they asked is indeed the question that is getting answered. Here we'll use the intents conversation name to represent the question. The conversation name is saved in a resource bundle entry, which you should be able to identify by the intents name in the bundle key. Add a send message state in front of the answer intent that references the conversation name's bundle key. Now, let's apply the display of the question to our previous example. As before, the value of the resource bundle entry is picked up by the flow. But this time, there's a state in the flow that picks up the conversation name of the intent as well. The flow then displays both the conversation name, the value of which is in the form of the question, "What are your opening hours?" and the response to the question. Now, let's take up the issue of context. The answer to a question may vary according to context. For example, the answer for a premium member may differ from the answer for others. Take these examples. How much is the discount you offer on electronics? Is shipping and handling free? To handle such situations, you can parameterize your resource bundle entries. Here's an example of a message string with a single parameter. And here's a more complex example where the whole message is parameterized using a complex format based on the ICU standard. This entry makes use of a select argument called membership. The possible values for membership are platinum and premium. The text that is displayed depends on the value of the membership argument. If the membership value is neither of those, the text assigned to other is displayed. Here's an illustration of displaying an answer that is based on contextual information. Once again, we'll use the opening hours example as an illustration. This time, after the user asks the question and the intent is resolved, the user is routed to a flow that enables them to select the store location. Here's what the dialog looks like after they have selected the location. Let's build on the previous example and insert a follow-up question in the dialog flow. The flow is the same as the previous flow, but now a state called Ask Next Question is added at the end. And at the end of the response, you see a prompt to ask another question. When using flows for answer intents, you can use a global flow, individual flows for given intents, or a combination of the two approaches. Use global flows to customize the way answers are displayed. You map the global flow from the answer intent built-in event in the main flow. Use individual flows to make distinct customizations to the display of given answers. You map individual flows for answer intents just as you do for regular intents. If you have a global flow for answer intents, but you have mapped an answer intent individually, the individual mapping takes precedence for that intent. Here's an example of using both individual and global flows. The hensa.store.openinghours individual flow has states for selecting a state, showing the answer title, displaying the intent, and asking a follow-up question. The global answer flow is similar to the individual flow, but it doesn't have a state for selecting the state. The Visual Flow Designer gives you a lot of control for how to display answer intents that you can take advantage of to better integrate them into your skill and make them more engaging and useful for users. In this lesson, we'll provide a general introduction to Dialogflow custom components. When your Dialogflow requires some functionality that is not provided by any of the built-in components, you can create your own custom components. In principle, custom components work in your Dialogflow in the same way that built-in components do. They expose properties, they can trigger action transitions, and they can render a bot response. The use cases for custom components are making back-end system calls and integrating custom logic into a conversation. You develop custom components using Node.js. Once your custom components are ready, you package them as a TGZ file and deploy them in a custom component service, which, technically speaking, is a REST service developed in Node. Custom components in Oracle Digital Assistant are based on a standard REST service architecture and support GET and POST methods. To develop components, you use the bots Node SDK. Once you have developed a custom component, there are several deployment options. The first one is to use a local skill component container. When you do this, the custom component resides in the skill itself. There are also several options for external deployment. You can use the Oracle Function Service on OCI. You can use the Oracle Kubernetes Engine, also in OCI, and you can use an external Node server. This has been a brief overview of what custom components are in Oracle Digital Assistant and how they can be deployed. In the next lesson, we'll go into greater detail about developing those components and integrating them with your skills. In this lesson, I'll show you the basics of using the bots Node SDK to start developing custom components and how to register a custom component service. After that, I'll go over some custom component best practices. The Oracle bots Node SDK is available to simplify custom component development. You can find it on GitHub. Before you can use it, you need to have Node.js and Node Package Manager (NPM) installed on your machine. The bots Node SDK assists with custom component coding in a number of ways. It reads from the request payload and writes back into the response payload without you needing to understand what the payloads look like. It also provides utility functions to do the following: read from input properties and write back to variables, generate user interfaces for prompts and messages, access other skills and request specific information, such as type of request and channel type. In addition, it can access information on the resolved intent and extracted entities. In addition, the bots Node SDK is indispensable for the practical tasks surrounding custom component services. You can use it to create a component service and custom components. It provides a command to package the component service for deployment, and it provides an embedded Node server for debugging and testing. Here are some things you can do to get started with the bots Node SDK. Create a Hello World custom component project using the bots Node SDK. Here is an example, and this is how you can package a component for deployment. Before you can get custom components working, you need to register their custom component service in the skill. First, you select the Components tab, and then click Add Service button to add a new custom component service registration. Then provide a meaningful name for the component that you will easily recognize when adding the component to the dialog flow. Finally, select a deployment option. Once the service is registered, the custom components in the service are displayed. You add custom components to the dialog flow using the Add State option as you would for built-in components. In the template menu, expand the service integration category and select Custom Component. Once added to the flow, the component appears like any other component would in the flow. Here are some things that you should do when building custom components. Build custom components with reuse in mind, or at least try to do so. Make sure the component name is unique. In the future, your components could be used together with custom components developed by a third party, so you'll want to make sure you can distinguish between them. Make no assumptions about anything outside of a component in the flow. Don't assume dialog flow variables to exist, and pass anything the custom component needs to know or work with as input parameters. There are some other things you can do to keep custom components simple and clean. Build integration and transformation layers, such as remote services that optimize data payloads for use in bots. Move reusable code logic into JavaScript libraries deployed with the custom component service. Document and image handling should be done in the cloud, especially if the custom component is deployed to the local skill container. Have an error handling strategy that takes into account back-end service access errors, input validation errors, and component exceptions. And finally, when handling any errors, make sure that you don't show error messages to users. They still think they are in a conversation. You should now have a good idea about how to start using the bots Node SDK to develop custom components, along with an understanding of good coding practices for those components. In this lesson, we'll quickly go over large language models and how you can incorporate them into digital assistants. So, what are large language models? LLMs are a form of what is known as generative AI. As you can probably guess by the name large language model, they are based on huge sets of training data. LLMs generate responses to user prompts, which are descriptions of the kind of output desired and not necessarily simple questions that have straightforward answers. Some LLM services include Cohere, OCI Generative AI, and Azure OpenAI. LLMs can bring a couple of things to digital assistants. Use of LLMs can potentially reduce the development time for chatbot solutions by reducing the number of intents that you need to create, and thus reduce the amount of training data that you need to provide. They also open the door to new conversational use cases, such as summarizing data and providing input within group conversations. You can prompt an LLM to do a wide range of things. Here are some examples. Provide a short summary of a piece of text. Write an essay on a given topic. Create a CV for a job application. Write code in a given programming language to solve a specific problem. In the prompts that you use when invoking an LLM, you can specify things like the writing style. For example, you could specify that it be written like a business letter, a technical spec, or a travel brochure. The tone of voice. For example, you could request serious, chatty, or whimsical output. The length of response. And provide concrete examples of the desired output. However, it's important to keep in mind that LLMs have their limitations. LLMs are indeterministic, so you don't have full control over the answers provided, including tone, branding, and even information provided. In fact, sometimes the answers are completely made up or, as some say, hallucinated. When used standalone, LLMs lack other features that are key to enterprise integration, ranging from multi-channel support to insights. When you incorporate calls to LLMs from chatbots based on the Oracle Digital Assistant platform, you can mitigate the limits and missing features in the LLM service. For example, when strict branding, messaging, and curated responses are required, you can design flows with deterministic responses. You can incorporate information from the conversation and other sources into calls to the LLM. You can expose digital assistants from multiple channels, including web, Microsoft Teams, Slack, and SMS. For times when it's easiest to interact with a form, digital assistants allow for rich form interactions with input fields, buttons, and so on. You can take advantage of Oracle Digital Assistant's insights metrics to evaluate things like traffic and skill performance. You can call multiple different LLM services, depending on which service works best for each use case, even in the same skill. How can you do these things? In Digital Assistant, you can create LLM blocks within a dialog flow to interact with an LLM. LLM blocks are dialog flow components that capture a single LLM-based step, such as extracting, summarizing, or generating content. They contain prompt instructions and mappings to the data to operate on. The actual calls to the LLM service are not exposed to users. Among other things, this prevents access credentials from being exposed. They can be chained together with other states and flows to create workflows and conversational experiences. You can use preceding states to gather and validate user input that will be used in the prompt. And you can use subsequent states to validate and post-process the LLM response. Here's an example of what you can do with LLMs in a skill. Say you have a digital assistant that helps you with your team's sales activities. You could use LLMs for a few purposes. First of all, you could build a flow to summarize the key details of a given sales opportunity. To do that, you could have a state extract the name of the opportunity from an entity in the user's input. Then, based on the opportunity extracted, you could pull up details of the opportunity with a REST call. Then, using an invoke large language model component, you could design a prompt that asks for a summary of the information provided in the REST call. Similarly, you could design a flow for writing emails to your team. For that, you could extract the desired audience, subject, and details from user input. You could then design a prompt with instructions for writing an email that uses the extracted information as parameters. In summary, you can incorporate calls to LLMs in digital assistants while taking advantage of the other features of the Oracle Digital Assistant platform. Digital Assistant's Visual Flow Designer enables you to use LLM building blocks to take advantage of the power of generative AI while incorporating it into conversational flows. In Oracle Digital Assistant, you can integrate LLM services into your skills. Both Oracle and third-party LLMs are supported, including OpenAI, Cohere, and OCI Generative AI. And you can configure multiple LLMs to take advantage of their varying relative strengths. You can access the LLMs through REST endpoints that they expose. And you can invoke the LLM in a conversation through the Invoke Large Language Model component in Visual Flow Designer. Within a skills dialog flow, you can design how an LLM is invoked and how its response is used. Calls to LLMs can be combined with or chained into workflows or conversational experiences. You can use prompt instructions, templates, and mappings to variables to invoke an LLM in a controlled and personalized way. Importantly, invocation of an LLM doesn't have to result in a direct response to the user. You can use other states in the dialog flow to post-process LLM responses and then present that result instead. Here are the general steps for adding an LLM to a skill. In your digital assistant instance, create a connection to the REST service for the LLM. You can do this in Digital Assistant's API services settings. You can use this connection in multiple skills. Then, in the skill, you do the following. Create an LLM transformation handler, which is a custom component that translates message payloads between the LLM's format and Digital Assistant's common LLM interface. Then create an LLM service to invoke the connection you created to the LLM and use the transformation handler you just created. Finally, insert and invoke large language model component in the dialog flow and configure it to use the LLM service. Here's what you need to know about the Invoke Large Language Model component. Like other Visual Flow Designer components, it can be dropped into flows and has configurable properties. Each instance of the component captures a single LLM-based step, for example, generating content, extracting information from existing content, or summarizing information. Within the component, you configure properties to specify the following. An LLM service that connects to the LLM and provides an event handler for the LLM's request, response, and error payloads. Prompt instructions. Prompt parameters that reference things such as entity values. In addition, this component provides a wealth of other options, including saving the response from the LLM in a variable so that you can further process the response, sending the LLM response directly to the user, enabling the user to refine the results, displaying standard buttons with the bot response, such as submit and undo, as well as any custom actions you may have provided. There are additional properties for things like temperature and maximum number of tokens. Prompt engineering is an iterative process. The prompt builder, which you can access from the Invoke LLM component's properties in the Visual Flow Designer, helps you create, test, and refine prompts. The prompt builder enables you to do the following. Test the prompt with different LLMs to find which one returns the best results for your use case. Generate example parameter values to test the prompt. Iterate through the tests until you are satisfied with the output. Once you have settled on the contents of the prompt, you can use the preview tester to test it in the context of the whole flow. This was a quick overview of how to incorporate LLMs into your dialog flows. In this lesson, we'll discuss what goes into a digital assistant, both at design time and runtime. Let's start with the answer to the most basic question. What is a digital assistant? A digital assistant is a concierge bot that combines individual chatbots into a unified user experience. Chatbots have come a long way since their early days of solving simple business problems, such as customer service automation, automation of structured processes, and self-service. Today's digital assistants are user-oriented and designed to assist users with various related or unrelated tasks. These assistants are context-aware, meaning they can learn about the user and the context of the conversation to provide more personalized and effective assistance. In other words, digital assistants deliver on what users really expect from chatbots. So, what are the basic principles behind digital assistants? Digital assistants orchestrate individual skills into a uniform chatbot solution. At its core, a digital assistant is a single front end that exposes multiple skills to a user. This configurable assistant intelligently routes user messages to the right skill. It can help disambiguate user requests with the help of auto-generated dialogues. Another important feature of digital assistants is the ability to handle non sequitur in conversations. You can create a digital assistant in several ways. Most typically, you'll create them from scratch. You can also use an existing digital assistant as a starting point by cloning it. If you already have a digital assistant but want to create a new version, you can do that too. Or you can import an existing digital assistant that has been exported from another instance. Once you have created a new digital assistant, you do the following to get it working. You add the necessary skills from the skill library of the Oracle Digital Assistant instance that you are working with. Click the Train button to create a training model that incorporates the digital assistant's system intents and the training models of the skills in the digital assistants. Configure any digital assistant settings that you want to customize, such as confidence thresholds and labels for smart dialogue prompts and messages. We'll go into greater depth about what you can configure later. Here's what you need to know about versioning and other digital assistant lifecycle features. When you create a new digital assistant or a new version, it starts out in draft mode. You can publish it to freeze its contents so that further changes can't be made. If you need to change a published digital assistant, you can create a new version based on that published version. Exporting a digital assistant creates an archive of its settings and all the reference skills. That archive can be imported to other instances of Oracle Digital Assistant. Each digital assistant has built-in system intents that handle general digital assistant requests. Those intents are help, exit, and unresolved intent. Each of them comes with pre-seeded training data, so that you don't necessarily need to come up with your own. However, you can extend that training data with your own utterances if you have that need. Here's what you need to know about the system intents. The help intent is for when a user requests help, or a menu, or when greeting the digital assistant. The help provided depends on the context of the conversation. If the user is in a conversation with a skill, then help is displayed for the current skill. If the conversation isn't already in the context of a skill, general help for the whole digital assistant is displayed. The exit intent is invoked when users express a desire to exit the conversation. The exit can apply to the current conversation or from all conversations. The unresolved intent is based on phrases that the digital assistant isn't designed to answer and includes built-in utterances for all the natively supported languages. When matched, a help menu is displayed. Digital assistants support two types of invocation, that is when the user requests functionality pertaining to a given skill: explicit invocation and implicit invocation. With explicit invocation, the digital assistant calls the skill directly. This occurs when the user has uttered the invocation name for the skill that is defined in the skill settings. With implicit invocation, the digital assistant evaluates all the available skills to determine the best skill to handle the user's request. This is done by analyzing the user's input and comparing it to the triggers and conditions defined in each skill. If a skill is found that matches the user's request, it is invoked to handle the request. This occurs when the user input implies the need for a skill without referring to it directly by its invocation name. One of the key features of a digital assistant is its ability to handle interruptions. If a user message references a skill other than the current one, the conversation is interrupted and continued later so that the user message can be processed by the other skill. In this case, the user is in the midst of a bank transaction but then decides to order a pizza. The digital assistant has a smart dialogue that appears and prompts the user to confirm the desire to switch to the pizza order. Digital assistants also have built-in support for handling ambiguous user input. If a request matches more than a single skill, a dialog is displayed for the user to choose from. In this case, the user has made a general account balance inquiry, but the digital assistant is aware of more than one account. So, it generates a smart dialog to prompt the user about which account to select. There are several ways to configure digital assistants. First of all, there are many routing parameters that you can set to tune the digital assistant's routing behavior. These settings include various confidence thresholds and margins and affect things like how strong of a match is required of user input for it to resolve to an intent. Conversation settings include prompts and labels for things such as smart dialogues that you can customize in settings that affect when system dialogues are displayed, such as when a user switches to another skill. You can also provide mappings to other skills for custom help and unresolved intent intents. As with skills, Oracle Digital Assistant provides an Insights feature for digital assistants. Digital Assistant Insight provides developers with information on usage patterns and insights on how users interact with their digital assistants. This developer-oriented analytics tool can help improve the assistant's performance and identify areas that need further development. It also has a retrainer that enables you to apply incorrectly resolved user utterances to the correct intents. You can test the behavior of your digital assistant as you develop it without needing to publish it or expose it on a channel. In the embedded conversation tester, you can test conversation flows, monitor variable values, and see how routing decisions are made. You can access the JSON message payload, and you can see when a conversation branches into a different skill. Using the tester not only helps you ensure the quality of the digital assistant, but also helps you understand the decision-making process in the routing. Just as it is good and common practice to have automated tests in software development, you should also have automated tests for your digital assistant. In digital assistants, conversation is the unit of testing. A part of the tester includes a facility for recording conversations during manual testing and saving them as test cases. These test cases can then be used to automate the testing process. The conversation tester also includes features to manage test cases, including the ability to create and execute test runs, view test results, and export test reports. These reports can be used to identify and fix issues in the bot's conversation flow. You may ask whether you really need to bother creating a digital assistant in all cases. And the answer is almost always yes. Digital assistants provide extra capabilities without requiring any user code. Even with one skill, using a digital assistant brings added AI capabilities that can enhance the user experience. For example, the digital assistant can handle interruptions to the flow and manage conversations across multiple skills, which can be useful if you decide to add more skills in the future. Additionally, the digital assistant comes with pre-seeded data for menu, exit, and greeting intents, which can save you time and effort in building these common components from scratch. Overall, even with one skill, using a digital assistant can provide a more intelligent and streamlined user experience, as well as valuable tools and insights for developers. In this lesson, we described digital assistants and their features, how to create them, and the reasons you would use them, even if you otherwise would only have one skill. In this lesson, we'll discuss the mechanisms that enable user input to be routed to the appropriate intent in the appropriate skill in a digital assistant. Let's first take a conceptual look at digital assistant routing and how it relates to human conversation. Human conversation seldom follows a single storyline. Conversations that go back and forth between topics and humans are easy to follow because our brains are capable of switching context without missing information. Digital assistants also have this capability. Acting as a kind of traffic controller, a digital assistant can detect topic switches. It routes messages to the most appropriate skill or intent, which could be a new flow in a current skill, a different skill, or a system intent. All the while, it maintains the conversation context. At the heart of the routing model are confidence scores, which are calculated for the individual skills and intents to measure how well they match with the user's input. Confidence scores are derived by applying the underlying natural language processing algorithms to the training data for your skills and digital assistant. Think of a digital assistant as an intelligent routing container of one or many skills. Here's a very high-level glimpse at digital assistant routing. A user message comes into the digital assistant through a user channel, such as Slack or a web application. Based on the combined training model of the digital assistant and its skills, the message is routed to the appropriate intent in the appropriate skill. We'll get into more detail a bit later. Here are some terms that we'll be using throughout this lesson to explain routing. The first one is implicit routing. This refers to when a user provides input that matches well with one or more skills and the digital assistant can route to an appropriate intent. Or, if there are multiple matches, the digital assistant can provide a smart dialogue to help the user choose the right intent. Explicit routing occurs when the user states the invocation name of a skill in their message. This is also called explicit invocation. You configure the invocation name of a skill in its settings. Candidate skills for the user message are determined when the digital assistant evaluates confidence scores for each skill against the candidate skills confidence threshold. Candidate flows for the user message are determined by evaluating each intent in the candidate skills according to the intent model for the respective skills. System intents are the three general intents that are built into the digital assistant: exit, help, and unresolved intent. Typically, when a user message comes into a digital assistant, the following general steps occur to determine where to route the message. The first stage is to determine whether the user input matches with any of the digital assistant system intents. It does this by comparing the confidence scores for the built-in intents against the built-in system intent confidence threshold setting. The next step is to determine the candidate skills for the input. The digital assistant does this by comparing the input's confidence scores for each skill against the candidate skills confidence threshold. The final step is to determine candidate flows. In the candidate skills, each intent is evaluated according to the intent model for each skill to determine the candidate flows. Let's look at a few examples of implicit routing. As our example, we will use a digital assistant with skills for banking, retail, and pizza. The first example will be a simple one. There is no active skill, which means that either the user has just started the conversation or that the previous conversation has ended. The digital assistant evaluates the user message, "Can I get a pizza?" against the bank skill and does not find a match. The same with retail. However, it does find a match with the pizza skill and gets a match to the order pizza intent with a confidence score of 0.9 or 90%. In sum, we can see that there is one candidate skill, which is the pizza skill. There are also two candidate flows, order pizza and cancel order, for which there is one match, order pizza. Now here's a more complex example. As in the previous example, there is no active skill, which means that either the user has just started the conversation or the previous conversation has ended. The digital assistant evaluates the user message, "What's my balance?" against the bank skill and gets a match. It will also match the retail skill. However, it doesn't find a match with the pizza skill. Ultimately, we can see that there are two candidate skills, bank and retail skills, and two matches, check balance and gift card balance. Since there are multiple matches, the user is presented with a smart dialogue that enables them to choose between the matches. The wording for those smart dialogues is configurable in the digital assistant settings. Now let's talk about how conversation context fits in. In the previous examples, the user was just beginning the conversation with the digital assistant, but we also need to consider the case where a user is already within the context of a conversation. A key feature of digital assistants in Oracle Digital Assistant is that they are context-aware within the conversation and handle routing accordingly. If a user is already engaged with a skill, that skill is given more weight during intent resolution than intents from other skills. If the user input includes an explicit invocation for a skill, but no intent-related utterance, the router pins the conversation to the skill. That means that the next utterance is assumed to be related to that skill. With that information on conversation context in mind, let's try another example of implicit routing. In this example, the user is already in a conversation with the bank skill. Perhaps they have just initiated a money transfer. The digital assistant evaluates the user message, "What's my balance?" against the bank skill and gets a match. It evaluates the message against the retail skill and also finds a match. It doesn't find a match with the pizza skill. Ultimately, we can see that there are two candidate skills, the bank and retail skills. There are also two matches, check balance and gift card balance. But check balance is selected automatically because of the extra weight provided by the conversation context. The routing behavior is a little different if the user uses the invocation name of a skill in their message. Each skill has an invocation name that you register for it in its settings. In this example, the invocation for the bank skill is Cash Bank, the retail skill invocation is Retail King, and the pizza skill invocation is Pizza King. When the user includes this invocation name in their message, the digital assistant explicitly routes to the corresponding skill and doesn't take into account confidence scores for other skills. For example, a typical explicit invocation might include the invocation name and a request. So, a user message of Ask Retail King to list all the stores would automatically resolve to the retail skill, and in this case, match with the list store's intent. In this lesson, we have talked about how digital assistants add a dimension of human contextual awareness to chatbot conversations through routing capabilities and have described digital assistant routing rules and scenarios, such as implicit routing, conversation context, and explicit routing. In this lesson, we'll focus on the configuration and testing that you do after you have assembled skills in your digital assistant. Let's start with a discussion of routing parameters. The values of the various routing parameters help determine how user input gets resolved. You can fine-tune the parameters to do things like require higher confidence scores for intents to match. You can also increase or reduce consideration of multiple matching intents, which affects how much users are prompted to disambiguate. The values for these settings are expressed as decimals between 0 and 1, where 0 means 0%, 1 means 100%, and for example, 0.5 means 50%. Here are some key routing parameters to consider fine-tuning. The candidate skill's confidence threshold is the minimum confidence score required to match a candidate skill. Typically, this has a relatively low value to make sure that skills aren't ruled out before candidate flows can be evaluated. Confidence win margin is the maximum difference between the confidence score of the top candidate skill and the confidence scores of any lower-ranking candidate skills that also exceed the confidence threshold for those lower-ranking candidate skills to be considered. The lower this figure is, the fewer disambiguation dialogues users will see. Consider all threshold is the minimum confidence score required to consider all the matching intents and flows. This value also takes precedence over the win margin. Consider only current context threshold is the minimum confidence score required when considering only the current skill and the digital assistant's exit intent. If user input matches an intent above this threshold, other intents are not considered even if they reach the confidence threshold. This setting is useful for preventing disambiguation prompts for user input that matches well with intents from multiple skills. For example, the user input cancel order could match well with intents in multiple food delivery skills. Here are some examples of how routing parameters can affect intent resolution for candidate skills. In this first example, the confidence scores for all of the skills exceed the confidence threshold of 40%, but because of the win margin value of 10%, only 2 skills qualify as candidate skills. Skill A with 78% is the top skill, and Skill B with 69% is within 10% of skill and also qualifies. In the second example, the skills have the same confidence scores as is in the first example, but Skill C also qualifies as a candidate skill because the win margin is 20%. In the third example, all of the skills qualify as the candidate skills because all of them reach the consider all threshold of 70%. Among the digital assistant settings are settings for how smart dialogues display. These include wording for messages and prompts when flows are interrupted, exited, switched, and resumed, as well as when no matches are found, and so on. There's also an interrupt prompt confidence threshold, which you may wish to lower the value of so that users are not prompted to confirm all interruptions. Here's how it works. When a user enters a message that interrupts the current flow, and the confidence score for that interrupting intent is greater than this threshold, the user is not prompted to switch to a different flow. Instead, they are just shown a message. By default, this property is set to 1.01, which means that a prompt will always be shown in the case of interruption. It is also possible to create custom handlers for the digital assistant's built-in intents. If you do so, there are settings that you can use to specify the skills and flows where you have defined these handlers. For each skill that you add to a digital assistant, there are settings that help dictate how the skill is used in the digital assistant. The enabled setting determines whether the skill is active or not. By default, skills are enabled, but you might want to temporarily disable a skill for various reasons, such as if the backend service it connects to is not available. The exposed setting affects whether the skill is explicitly named in any smart dialogues. By default, this setting is turned on, but you may want to switch it off for skills that handle tasks like politely managing irreverent user input. For example, if you have an intent for deflecting user messages with profanity, the user would never see a prompt asking if it wants to switch to the profanity flow in the irreverent messages skill. You can designate a group for a skill to have it treated as being part of the same context as other skills in the group when routing decisions are made. In the example utterances field, you can enter utterances that appear as options when help for the skill is displayed. The conversation tester in the digital assistant can be used to test the conversation routing within skills and across skills. As in the conversation tester for individual skills, the conversation tab shows dialogue flow states, as well as variables and their values. The digital assistant conversation tester also has a routing debugger to help you understand the logic behind routing decisions and give you ideas about how you might fine-tune routing parameters. It includes a section for rules invoked. These include things like when there is an explicit invocation or when a strong match with the skill in the current context causes flows from other skills to be ignored. And it shows the confidence scores for system intents, candidate skills, and candidate flows. This is probably the part of the digital assistant tester you'll use most. The JSON view shows the raw payload that is exchanged between the simulated client and the tester and the bot. We won't explore that in this lesson, but you can look at it on your own when testing your digital assistant. To give you an idea of how you can use the routing tab in the tester, let's look at a few examples. First, we can see that the user has entered "Tell me my balance" and receives a prompt asking for which account to query. Now, let's examine the routing information to see how we got that response. In the candidate skills section, we can see that 2 skills have exceeded the confidence threshold of 40%, but only one skill, GR Finance for DA Starter 22, passes the candidate skill evaluation. This is because the consider all confidence threshold of 80% is too high for the other skills to be considered. With the candidate skill determined, the intents for that skill are evaluated, and the results are shown in the candidate flows section. In this case, only the balance's intent reaches the threshold. Thus, the user sees the response that correlates with the balance's intent. Now let's look at a disambiguation example. In this case, the user's balance inquiry results in a disambiguation dialog. Looking at the candidate skills section, we can see why. Both the finance and retail skill match with 100% confidence, which exceeds both the candidate skills confidence threshold of 40% and the consider all confidence threshold of 80%. Since both of those skills are candidates, the intents for both of them are evaluated, and each has one intent that matches gift card balance and balances. Thus, the disambiguation dialog appears in the conversation. Now we'll look at an example where current context plays a role. In the beginning of the conversation, the user has asked about savings account balance and received an answer. The user then asks about balance again and receives an answer from the balances flow from the banking skill. Why wasn't there disambiguation here? After all, in the candidate skills section, there are matches to 2 skills. And in the candidate flows section, there are matches to 2 different flows. However, in the current context section, only balances from the banking skill matches. So, the digital assistant routes to that flow without asking for disambiguation. In this lesson, we have discussed further details of digital assistants, including fine-tuning routing behavior and other digital assistant configuration as well as walking through the routing debugger in the conversation tester. In this lesson, we'll take a high-level look at user channels, which are the mechanism for connecting a digital assistant with user messaging clients, like Slack and web apps. Channels are configurable adapters that connect digital assistants and skills to messengers or endpoints to exchange messages. This lesson is about user channels, but let's quickly introduce the other Oracle Digital Assistant channel categories as well. User channels connect users with digital assistants through web pages, mobile apps, and popular messaging clients like Slack. Agent integration channels help integrate digital assistant with CX services. There are two approaches to this. In the first, you integrate a digital assistant as an agent, where the digital assistant is a peer-to-live user agent, though it can also pass control to live agents when necessary. On the other, the digital assistant handles the initial conversation with the user, but can pass control to a live agent if it can't resolve the user query or issue itself. Application and event channels allow external applications to trigger a user conversation through the bot sending an initial message to a user. Finally, the system channel is used for the embedded conversation testers for skills and digital assistant. You won't create channels from this one. User channels convert message formats between the digital assistant and messaging client to ensure optimal rendering of the digital assistant responses. Oracle Digital Assistant has a set of built-in channel types that handle all of the message dispatching and payload transformation that is needed and only require declarative configuration. No custom code is required to connect a digital assistant to the messaging client. For unsupported messaging platforms, you can create custom channels using the webhook channel to access a custom endpoint that will handle the user-to-bot interaction. Here's a list of the channel types that are supported out of the box. Among these channel types are Oracle Web, Oracle Android, and Oracle iOS, all of which come with an SDK that enables you to customize the chat widget and experience. Different messaging platforms have their own conventions for creating rich text formatting. To simplify creation of rich text messages for multiple user channels, Digital Assistant allows you to use standard HTML tags in your skill and Digital Assistant responses. At runtime, the HTML tags are automatically replaced with messenger-specific equivalents, which ensures that the formatting is optimized for each individual messaging channel. If there is no direct equivalent, the closest equivalent is used to maintain the formatting consistency. In Oracle Digital Assistant, configuring user channels is a straightforward process. For built-in channel types, you just need to do a bit of declarative configuration to get the channel up and running, including setting up any authentication and other fields required by the messaging provider. You then route the channel to a skill or digital assistant and set its channel enabled to switch on. User channels are also reflected in the conversation tester. When you use the conversation tester for skill and digital assistant testing, you can select a channel type to simulate the behavior of the client channel. When you do so, you are notified of any relevant channel constraints regarding things like message size, layout limitations, and lack of support for postback actions, which can help you diagnose any potential problems with your messages and the channel ahead of time. You can also record automated tests for the channel. However, using this feature in the tester does not replace real testing with the messaging client. Here's a quick example of how the tester can help you understand the way messages are rendered in channels. On the left, you can see that the tester is set up to simulate an Oracle Web channel and that it has a carousel that supports horizontal display of cards. On the right, you can see that the tester is set up to simulate a Slack channel and that it does not support horizontal cards, so it displays them vertically. But what do you do if there isn't a built-in channel for your preferred messaging platform? You can use the webhook channel type for custom integration of unsupported messengers. When you create a webhook channel, you need to write code to connect to the platform and transform message payload formats. This may require a custom message server. Coding for webhook channels is supported by the Oracle Bots Node SDK, which provides starter code and has utilities for transforming digital assistant messages. With some user channels, it is also possible for users to communicate with a digital assistant verbally. In this chat widget, you can see a microphone icon, which you can click to activate speech recognition. Oracle Digital Assistant's SDK for the Android iOS, and web channels come with integrated speech recognition capabilities that enable users to use their voice to interact with digital assistants. It's also possible to create webhook channels to integrate with other voice platforms such as Alexa, Google Home, and the Twilio Voice API. In these cases, the voice command is first sent to the messaging provider's server, which then forwards it to the digital assistant via webhook. In this lesson, we provided information on the built-in user channels that you can easily set up to provide access to your digital assistant through various messaging platforms. In this lesson, we'll take a look at the basics of creating web channels for your digital assistants. The integration of Oracle Digital Assistant on web pages is an extremely common customer use case, so let's take a look at how that integration works. To facilitate this integration, Oracle provides a web SDK that you can use to place a chat widget on a website or in an application. Using the SDK, you can customize the look and behavior of this widget. You then use a web channel that you create in Oracle Digital Assistant to expose your digital assistant or skill to the widget. Oracle Digital Assistant's Web SDK supplies a ready-made web messenger widget, which is a pre-built chatbot interface that can be easily added to any web page or web application. It can be used as a pop-up window or embedded directly into the page. The widget also offers declarative look and feel customization, allowing you to easily customize the appearance of the chatbot interface to match the design and branding of your website or application. Additionally, the widget provides voice support, allowing users to interact with the chatbot using speech-to-text and text-to-speech capabilities. For more advanced customization, the widget includes a JavaScript API that provides programmatic access to the chatbot functionality. This API enables developers to send messages, intercept user messages and bot responses, and perform other advanced interactions with the chatbot. The widget communicates with the chat server in Oracle Cloud, ensuring that all messages are securely transmitted and processed by the chatbot engine. The widget also includes an attachment server that enables users to upload and share documents and other files with the chatbot. Web channels, which you use to connect your digital assistant with your web chat widget, can be configured in the Oracle Digital Assistant. Just like other user channels, they are configured declaratively, which makes them easy to set up and customize to meet the needs of different use cases. Additionally, the web channel supports zero downtime configuration, which ensures that changes can be made to the configuration without disrupting the user experience. To provide secure access control, the web channel supports domain allow listing, which allows developers to specify which domains are allowed to access the digital assistant. The web channel also supports optional JWT token authentication, which provides an additional layer of security for sensitive interactions. To ensure secure communication between the web channel and the chatbot engine in Oracle Cloud, the web channel uses a secret key that is securely shared between the two. This ensures that all messages are transmitted securely and that unauthorized parties cannot access the chatbot or intercept messages. Here are things you can configure when you set up a web channel. The channel-enabled feature allows developers to take a channel offline when necessary, ensuring that users cannot access the digital assistant when it is undergoing maintenance or updates. The route to feature binds the channel to a specific digital assistant or skill, ensuring that incoming messages are directed to the appropriate digital assistant. Allow domains enables you to define which domains can access the digital assistant through the web SDK, ensuring that only authorized domains can interact with it. The secret key feature is necessary when client authentication is set to enabled, ensuring that only authorized clients can access the digital assistant. The channel ID is a unique identifier required for web messenger configuration, enabling the digital assistant to be accessed through the web messenger widget. Finally, the client authentication enabled feature requires clients to pass a secret key or JWT token, ensuring that only authorized clients can access the digital assistant and preventing unauthorized access or interception of messages. You can access the Web SDK from the Oracle Digital Assistant documentation pages. Go to bit.ly/odia-doc. In the left navigation of the page, click SDK References. On the SDK download page, click the Client SDK link. On the Downloads page, under Oracle Native Client SDK References, click the download link for the Oracle Web SDK. Adding the web widget to a web application or website takes just a few steps. Once you have downloaded and extracted the zip of the Web SDK, do the following. In the extracted zip file of the downloaded Oracle Web SDK, locate the sample Web SDK and settings.js files and copy them to your web application or site. Edit the settings file with your channel details. Finally, add the JavaScript reference to your website or application. In this lesson, we provided information on the built-in user channels that you can easily set up to provide access to your digital assistant through various messaging platforms. In this lesson, we'll show you how to do a basic customization of the Web Messenger widget declaratively. The easiest way to configure and customize the Web Messenger is to use an external configuration file like the one used in the Oracle Web SDK sample. By using an external configuration file, you can modify the settings of the Web Messenger without having to modify the underlying code. Furthermore, this approach enables you to quickly deploy the Web Messenger on multiple websites or applications, while maintaining a consistent look and feel across all instances. You can use feature flags to enable or disable features for the Messenger widget. These features include a clear message button, opening the chat window when the page loads, speech recognition, headless use of the SDK, and many more. Feature flags take the form of properties that you can set declaratively or optionally using JavaScript upon the Messenger start. Note that these properties cannot be changed at runtime after the Messenger has started. A common requirement for customers using the Oracle Digital Assistant Web Messenger is to display a message from the bot when the messenger is first opened. This can be achieved through a hidden message sent to the bot upon the start of the messenger. This message is handled by the bot just like a regular user request. However, the user sees only the bot response, so it appears as if the bot initiated the interaction. There are two options for sending a hidden message to the bot. The first option is to use the init user hidden message configuration property, which allows developers to specify the message that should be sent to the bot upon the start of the messenger. This message will be hidden from the user, and the bot's response will be displayed in the messenger as if the bot had initiated the conversation. The second option is to use the bot's send message function call to send a hidden message to the bot programmatically. This approach provides greater flexibility, enabling developers to send hidden messages based on user interactions or other conditions. The Web SDK provides several options for customizing the look and feel of the Web Messenger. For starters, you can change the colors and fonts. There are 3 predefined themes available for the Messenger: Redwood Dark, Dark Blue, and Light Blue. These themes can be easily applied using the theme configuration property. You can also create custom themes by defining your own CSS styles. This allows for greater flexibility and enables the Messenger to be customized to match the branding and style of the application or website. In addition to customizing the colors and fonts, you can use CSS styles to adjust the position of elements within the Messenger. Custom icons can also be used in the Messenger by setting the icon configuration property. Finally, you can use CSS class customization to modify the appearance of individual elements within the Messenger. You can also declaratively customize the strings that are provided for the Messenger widget's labels, tooltips, and alt text. You can support multiple languages for the Messenger by providing translations for its strings. At runtime, the browser locale is used to determine the language of the strings to display. The default language is used if no translation is found. You may also find it desirable to initially display only part of longer messages. The Web SDK provides a way to split messages into multiple parts, making it easier for users to consume them. To split messages, you can specify a known delimiter, such as a line break or a specific character. When a message is split, only the first paragraph is shown to the user, with the remaining paragraphs hidden. Users can then expand the message to see the full content or continue with the chat. To implement this feature, you can use an ICU message bundle for channel-specific messages, and then add the delimiter to the message in the resource bundle. To filter messages by the delimiter, you can use a delegate object that intercepts the messages before they are displayed in the Messenger. The delegate object can then split the message based on the delimiter and only display the first paragraph to the user. To give you an idea of the customization that is possible, here are some examples of different implementations, with different styling for various parts of the interface, such as in the buttons, fonts, colors, labels, and icons. This has been an introduction to customizing the Web Messenger widget using Oracle Digital Assistant's Web SDK. As we have shown, you can do a lot of customizing of your widget in a straightforward declarative way. For more involved customization, you can use custom CSS and JavaScript. In this lesson, we'll talk about how to use resource bundles to facilitate the creation of multi-language digital assistants and digital assistants with adaptive design to work well on multiple channels. We'll also touch on other advantages of resource bundles and why you should always use them. In each digital assistant and skill, you have a variety of strings of text coming from different places. This includes the default prompts and messages in digital assistants. It also includes the dialog flow, answer intents, entities, configurations, and custom code in skills. Resource bundles in Oracle Digital Assistant allow you to store all your text resources in one place, making it easier to manage and update your text resources and keeping them out of the source code. You should use resource bundles everywhere in your code without exception. This improves the user experience and reduces the risk of errors. Resource bundles are an absolute requirement for multilingual skills, but resource bundles help in other ways. They are also required for multi-channel skills and digital assistants, where you use an adaptive response approach to tailor the responses to each channel, and they have the practical benefit of helping you to organize your messages. And this benefit greatly simplifies the work of the bot's copywriters. Both skills and digital assistants support resource bundles. You can start by creating a default bundle that defines messages for the base language. Additionally, the platform allows for importing and exporting of bundles for easier management. To keep your bundles organized, you have different categories, user-defined, where you create entries for messages in your dialog flows, and anything else not covered by the other categories. You have intents for intent display names, Q&A for answer intents, and configuration. To manage resource bundles, in the Oracle Digital Assistant, you should open the editor with the Add Bundle or Add Key button, or by selecting an existing message and clicking the Edit icon. Each resource bundle entry has a key, which is used to reference the message within the bundle. The text field contains the string that will be displayed to the user. Use the annotation field to provide additional information or context for the message. This can be useful for translators, copywriters, or for tracking changes made to the message over time. When creating resource bundles for your skills and digital assistants, there are some best practices that you should consider. First of all, the key names must all be unique within the skill. To make your key names more descriptive and informative, we recommend that you add context to them. This could include information about where the key is used, such as the entity, dialog flow, or dialog flow state. You could also include information about what the key represents, such as a prompt, error message, label, or keywords. By following these best practices, you can make it easier to manage your resource bundles and ensure that your messaging is consistent and clear. Additionally, descriptive and informative key names can help you quickly identify and update specific resources, saving you time and effort in the long run. The Message Bundle panel in the Oracle Digital Assistant provides two view options for managing message bundles. The View Message Strings by key show all translation strings for a resource bundle key name. It allows you to easily compare language translations with the base message string. This view is particularly useful for identifying missing or incorrect translations and updating them accordingly. The view by language shows all resource bundle keys for a particular language. It allows you to search messages by key names and by message content, making it easier to find and update specific messages. This view is particularly useful when creating new translations or modifying existing ones, since bundle keys that have a translation for the selected language are not displayed in the list, giving you a view of what needs to be translated and what has been translated. A missing translation of a message does not mean the end of a conversation with digital assistants. The language that your digital assistant uses to communicate with users can be detected automatically or set through a configuration. If the user's language is detected, the profile language tag built-in variable holds the two-letter country code for that language. Alternatively, you can set the language manually using the set variable template. If the profile language tag variable is set, your digital assistant will attempt to look up message strings in the corresponding language. If no translation is found, the assistant will default to the base string. To enable your digital assistant to communicate in additional languages, you can use a translation service or enable one of the natively supported languages. This will allow your assistant to understand and respond in multiple languages, providing a better user experience for a broader audience. In this lesson, we covered why and how to use resource bundles. Remember that using resource bundles is a best practice, even when you are not planning multi-language digital assistants. In this lesson, we'll cover the basics of creating multi-language digital assistants, including variants based on native language support and translation services. Let's step back for a second and think about what businesses who are developing a digital assistant typically want. Customers are looking for a single digital assistant that can serve multiple languages. This assistant should be capable of handling regional differences and providing a seamless experience for users across different languages and cultures. Ideally, they should be able to develop the digital assistant in their native language, while keeping all data securely stored within the Oracle Cloud. This would provide a comprehensive solution for businesses looking to offer multilingual support, without compromising on privacy or performance. Oracle Digital Assistant assists with all of these aims. Concerning multi-language support, Oracle Digital provides two language modes: translation services and natively supported languages. Now, let's do a little side-by-side comparison of these options. Translation services support a large set of languages, including many not included in Digital Assistant's native language support. The native language support includes a core set of languages including Arabic, Dutch, English, French, German, Italian, Portuguese, and Spanish. You may want to check the documentation for any possible new additions to that list. When you use a translation service, the service detects the user language and translates incoming messages to English, which Digital Assistant uses for intent resolution. With the native language support, there is a pre-trained multi-language natural language understanding model that is used for intent resolution, and you can add your own training data for each language, which generally makes intent resolution more accurate than when using translation services. Translation services can be used to translate outgoing messages to users, but in most cases, you should use resource bundles for the target languages to have more control over the text. With the native language support, you must use resource bundles for outgoing messages. The supported translation services are OCI language, which is provided by Oracle, the Google Translation API, and Microsoft Translate. When designing a multilingual chatbot, the choice of language mode is a critical first step. Whenever possible, using the native language support is highly recommended. This approach ensures that the chatbot is capable of understanding and processing user input natively in each language, resulting in a more natural and accurate conversation. Let's spend a few slides talking about working with translation services. We'll start with setting up the translation services. To enable translation services in Oracle Digital Assistant, you go to Settings and select Translation Services. Once configured, the translation service will be available for use, but it will not be automatically applied to a skill. Once you have set up the translation service for use in your digital assistant instance, you can configure skills to use it. It is important to note that the translation service setting is only available for skills that have been created with a primary language from the translation service list. This means that if you want to use a specific translation service within a skill, you must select a primary language that is supported by that service when creating the skill. Once the skill has been created, you can then go to its settings page to set the translation service. Now, let's spend a minute talking about what you need to do in the dialog flow for skills that use translation services. To make it easier to work with translation services in Oracle Digital Assistant, 3 component state templates are provided. The detect language template is used to automatically detect the language of the user's input and set the profile.language tag accordingly. This ensures that language-specific resource bundles are used throughout the conversation, providing a more seamless and natural experience for the user. Be sure to add it to all of the flows in the dialog flow. The translate input translates the user language into English, and the translate output translates output messages to the user language. Now, let's talk about working with the native language support in Digital Assistant. To get started, when creating a new skill, you need to select one of natively supported languages as the primary language. The natively supported languages appear first in the dropdown when selecting the primary language. You can then add secondary natively supported languages in the skill settings. When users start interacting with such skills or digital assistants, the language is detected automatically. No language or translation components are needed in the dialog flow. However, you need to create resource bundle entries for outgoing messages in each target language. In previous slides, we have talked about the pre-trained multi-language models that is used in the native language support. Let's step back for a second and discuss the conceptual background of how this works. Text is encoded into high-dimensional vectors, which are arrays of numbers. Each element in the array represents a single point in vector space. This process is commonly referred to as embedding, and it allows us to track similarities and relations between different texts. Skills start with pre-trained models with these embeddings, and you can then refine them by adding training utterances specific to your use case. This process allows for more accurate and tailored results as the model learns to associate specific words or phrases with certain contexts. How does this work with Digital Assistant's native language support? Modern language models are capable of mapping sentences from multiple languages into a single vector space. This allows us to compare the similarity between different sentences, regardless of the language they are written in. By measuring the distance between vectors in this space, we can determine the semantic similarity between different sentences. In Digital Assistant, the pre-trained models support multiple languages, allowing us to work with text from those languages right out of the box. Once you have created a skill with native language support and have added intents, you can work on the multilingual training model. You need to start with utterances in the skill's primary language. You should find that zero-shot training, meaning training with no utterances in your secondary languages, is still good enough to provide basic language understanding, though it might not provide quite the quality of intent resolution that you are aiming for. Once you have a robust set of utterances in the primary language, start testing the skill, including with test utterances from the secondary languages. Based on the results, use a few-shot approach to incrementally add training utterances in the secondary languages to improve the intent resolution for those languages until it reaches your target accuracy level. You'll want to create enough secondary language utterances to complement the primary language training data. Here are some tips for doing that. Don't just use machine translation services for this purpose. Any enhancement that they provide to the model is likely to be limited. However, you will want to involve native speakers in generating utterances. They are likely to provide you with equivalent ways to expressing things that are not just literal translations of the words. A good rule of thumb for each secondary language is to add 20 to 30% of the utterances that you have for the primary language. In this lesson, we went over the basics of support for multi-language digital assistants. Depending on your requirements, you can use Digital Assistant's native language support or a translation service for your skills and digital assistants to support multiple languages. If the languages you need are natively supported, it is recommended to use that native support. In this lesson, we'll go through some miscellaneous information and additional steps you need to take to optimize the effectiveness of multi-language digital assistants. Let's start with some notes on working with entities for multi-language skills. Values of value list and dynamic entities generally need to be translated. This is particularly true if you need to display the values in the user language, such as in menus. For skills using the native language support, you can provide the translated values for each entity directly. Each language has a tab for you to do so. For translation service skills, there isn't a per language UI for entity values. you need to rely on the translation service to display translated values in the menus. However, you can use synonyms to improve recognition of entity values in user input. Finally, another advantage of the native language support is that it works for built-in entities like datetime out of the box. And as we discussed in a previous lesson, using resource bundles is an important part of creating high-quality skills. Even when using translation services, you should use resource bundles for all outgoing messages. This enables you to stay in control of how all outgoing foreign language messages are expressed. At runtime, the proper language message will be accessed from the resource bundle. Skills using native language support cannot be mixed with skills using a translation service in the same digital assistant. When building digital assistants with multiple skills, it's important to think carefully ahead of time whether to use native language support or translation services for language processing. All skills in the digital assistant must use the same approach, native language support or a translation service. If you choose to use native language support, all skills must support the same primary and secondary languages. This ensures consistent language understanding and a better user experience across skills. On the other hand, if you choose to use translation services, you must ensure that all skills are configured to use the same translation service. Here's a tip for future reference. You can use the profile language tagged expression in Skills and Digital Assistant to access the two-letter code of the detected language. Here's an important note for digital assistants that use a translation service. For each skill in such a digital assistant, you need to set the detect language component's existing profile language tag property to true. This ensures that the skill recognizes the language of the users. If you don't set this property to true, the skill will set its profile language tag variable to English, since the digital assistant sends the skill English text that has been translated from the user's language. Now, let's talk about configuration in the digital assistant itself. If you want your digital assistant to support multiple languages, you need to select both the primary language and the language mode, either natively supported or translation service, when you create the digital assistant. For digital assistants in natively supported language mode, you can add secondary languages on the General tab of the Digital Assistance settings page. Just as with messages output by skills, you should make maximum use of resource bundles for your digital assistant. Make sure the digital assistant itself has resource bundles entries for all of your supported languages. This includes any custom resource bundle entries and all the built-in entries like the one-sentence description, and invocation fields, and the example utterances used to invoke skills in the digital assistant. When using native language support, you get pre-seeded training data for your system intents for both your primary and secondary languages. With native language support, you can also add training utterances for the system intents. If you are using a translation service, you don't get the pre-seeded data or the ability to add training data separately for each language. That's it for this lesson, in which we have tied up some loose ends on configuring multi-language digital assistants, including entity translation, language detection, and maximizing use of resource bundles.